Hello everyone, how are you all? I hope everybody is doing good and well. Yeah, everything seems to be good. So I hope you guys remember my name. That's what matters to me. That is something which matters to me. For those who have come or who are attending for the first time, let me tell you, my name is Ayush, and I'm taking the chapters of class 11 JEE Mains and Advanced for you all. So let's study. Today we are going to do a very important or very basic topic. We can also call it basic topic, but very important topic. And why am I calling it important? Because entire math which you will be studying in class 11 or let it be in class 12, all of it is going to be connected to this chapter. You can call it like a backbone of entire math. So if we are not strong at trigonometry, then entire math seems to be or appears to become very difficult or challenging for us. Okay, so let's get to know a few things about the chapter. Some disclaimers are there. One of the most important chapters for JEE preparation, for entire JEE preparation, this is going to be one of the most important chapters. And the concepts, the formulas, most importantly the formulas, the chapter is going to be full of formulas. So be prepared to have a lot of mugging up. Definitely we have to mug up. Why? Generally I don't ask students or I don't ask people to mug up things in maths. Everything in maths can be explained, related or correlated, but for this particular chapter I'll request you to directly remember the formulas. Although we'll have explanation, we'll have derivations, we'll do everything to explain, to understand, but still it's better that we remember the formulas because we need pace in the examination. Guys, we don't have a lots of time in JEE Mains or be it JEE Advanced. We don't have a lot of time. We have fixed amount of time and we have to manage it. To manage it, we cannot keep on deriving the formulas. And how do we remember formulas? So we'll talk on the way while understanding the chapter or learning the chapter. We'll understand how to remember. Main or the most important thing or the easiest way which I can say is that you have to practice a lot of problems. The more amount of problems you solve, the better you'll remember. Your memory, these formulas, these identities, these functions will be stuck in your mind for these 2 years at least, 1 or 2 years at least, right? So that you can use them in calculus. A lot of trigonometry is there everywhere. In physics also you might have to use these same formulas. So let's understand that why we need trigonometry. Why do we need to understand all these formulas? Because the one important point which I told you is that you'll use them, you'll need them everywhere, and with practice you'll actually remember these formulas. There won't be any problem. What all are we going to cover up? A lot of things, so it is going to take time. So I'll request all of you to stick tight, have a pen and paper, pen or copy or notebook, whatever you use. Make note of these formulas. I'll try to explain as much as possible, right? So that you don't have to actually worry about mugging up or how this came or how that came. So note down things. Without noting down, it's just like a movie going on, and math cannot be read just by listening or watching or reading. You have to actually use your hand. You have to actually work for solving, and that's how you'll actually gain math. So let's start. Everybody ready? Please tell me in the comment section if you're ready. How do you feel about this chapter? Any comments on this chapter? Anything you already have pre-assumptions for this chapter? Please let me know. Yes, offline. Aditya is asking, sir, have you taught in offline as well? Yeah, definitely. Yes, Nikhil. Let's go. Okay. Don't worry, whichever class you are in right now, if you're in 12th, it will be a good revision. You must be getting the feeling that we get to use these formulas at so many places, so many times, and we keep forgetting how to apply many concepts, allied angles, compound angles, you know, simple definitions of cos theta, sin theta, triple angle, or some identities, transformation formulae. These things are, you know, these parts are one critical part of the chapter. Compound angle, multiple angle, many times you'll get to use, right, in physics. Just like Aditya, or who said, Nikhil said, I think, in harmonic motion. Yes, definitely. Many places, physics mein, a lot of places you'll get to use these formulas. So I was saying that whichever class you are into right now, be it 9, 10, 11, 12, if you are preparing yourself to be competitive or fighting a competitive examination, here we are. This is going to be a very beneficial session for you. Stick tight. I'll try to keep it as short as possible, but you know, there are so many topics, so I can't help it actually. It might go beyond a desired time which you might be thinking, but still, we'll try to cover up as fast as possible and understand as better as possible. Don't worry about it. Okay, so few basic things. Let's start with few basic things. So far we know about sine. What do we know about trigonometry? We know sine theta is perpendicular by hypotenuse, cos theta is base upon hypotenuse. We know tan theta is P by B, that means perpendicular upon base. Then we know their reciprocals. Then we know a few identities like sine square theta plus cos square theta is equal to 1. Right? All these identities, 3 identities we remember, and we know how to manipulate them. We have a basic idea about the entire trigonometry that we have learned in our previous class, 10th class, or if you are preparing now, then you must be going on with trigonometry. So don't worry, you'll get this chapter definitely. Now let's start with the first thing. Very catchy name, I would say. A catchy name is there. We don't have to worry about the name, nothing. So actually many mathematicians, you know, mathematicians are very interesting people. When they don't find, you know, much thing to do in the world, anything is not changing in the world, they'll discover systems, they'll discover things. And India has given one of the greatest mathematicians. So we have a lot, we have some systems different. So far what trigonometry which we were understanding or learning, we were relating it to kind of similar triangles, right? Like this. If I say, however, so far we have been, the trigonometry which we were doing was related to kind of similar triangles, right? We'll say that, okay, this triangle is there, then one more triangle is there. All right angle triangles are actually similar to each other if one angle is common in them. And that's how we understand that, okay, sine theta is the name of a ratio, which is the ratio of perpendicular by hypotenuse. Right? We know that cos theta is the name for a ratio. The ratio is base by hypotenuse. Now we'll go a bit further. The more discoveries, the more knowledge of trigonometry we'll try to understand. One basic thing that we know is one right angle is equal to 90 degree. Everybody knows that? Anybody who doesn't? One right angle is equal to 90 degree. Come on, tell me. Okay, we know that. We know that very well. One right angle is equal to 90 degree. That we know. Okay, so 90 degree, this degree concept or this degree name is used in hexadecimal system. When we are using hexadecimal system, we are using degree. We are saying one right angle is equal to 90 degree. Then mathematicians were like, let's do something more. This is not very enough. What if we want a shorter angle? We want something, some shorter unit, some smaller unit. Okay, so one right angle, how do we know about one right angle? We know that, okay, 1/4 of a circle, that means this part is going to be a right angle triangle 90 degree. Now, if we divide this into 90 parts, if we divide this thing itself into 90 parts, how many parts? 90 parts. So what do we get? We'll get 90 parts, sir. What else we'll get? We'll divide one right angle into 90 parts and we'll get 90 parts. So 1 degree, 90 parts. So 1 degree, one part will be equal to 1 degree. So can we see 1 degree? Can we imagine a little bit about 1 degree? Yes, we can. We can imagine about 1 degree also. So what will be 1 degree? 1 degree will be something, let's say like this. I'm just zooming it. So let's say this is 1 degree. Okay. 1 degree, shorter angle, smaller angle, no problem, zoomed angle, right? Magnified or zoomed angle. Now after this we had more time to explore. The mathematicians had more time to explore. So what they did is they divided this also into 60 parts. 60 parts, and they called it 1 degree means that is 60 minutes. And the sign they used for minutes, maybe they were convinced or influenced by the clock system. Definitely, I'm not exactly sure about that, but yeah, something like this. They divided 1 degree into 60 parts. And 1 degree was divided into 60 parts, and those parts they called minutes. So 1 degree was equal to 60 minutes. Still they were not satisfied. They were like, let's shorten it. Maybe they were thinking that what if the next generation or the other generation will be having to get more of shorter angles. What if they need more units? So let's do more. Let's write some more books. Anyway, we are not doing anything, and we have researched about entire math, so much math in the world. So let's do something more. What they did is they said, okay, one minute. Now 1 minute even will be smaller, right? I'm zooming 1 minute. This is 1 minute, right? This thing is just 1 minute. This particular thing is 1 minute. So 1 minute looked like this. This angle is 1 minute. Now everybody knows 1 minute is equal to 60 seconds, right? So yeah, 1 minute is equal to 60 seconds. Now 1 minute was also divided into 60 parts, and then each part was called a second. So 1 degree equal to 60, 1 minute is equal to 60 seconds. Again they divided into 60 parts. Are we getting it? Any problem till now? Simple thing to understand, 60 parts. Okay, ji, no problem. So what did we understand from here? We understood that 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. Simply we'll write. Okay, let's just remember this thing, and very easy to remember also. 1 right angle is equal to 90 degrees, that we know already. What do we understand? 1 degree. Here what do we understand? We'll understand that 1 degree is equal to 60 minutes, and minutes will represent like this, and 1 minute is equal to 60 seconds. Okay, no problem. That's cool. Too many units, very short angles. Even if we want to 1 second, in fact I would say, we cannot see that angle from our eyes. We cannot see that angle without a microscope or a zooming glass or magnifying glass or something. Very small, very thin angle. But that's what we needed, right? We had science, we had so many things, we had the world had so many expectations from the mathematicians, so they did it, no problem. Okay, after that came circular system. Then there were some other bunch of mathematicians, and these mathematicians who were giving hexadecimal system were not gelling up properly with the other mathematicians. So other mathematicians, what they did is, okay, I'm not comfortable with this minute second, because it's going to confuse me between the clock and trigonometry. So many things are there. I'll come up with something else. So see, they came up with even a better or even more defined idea. That was circular system. Right, that was circular system. So 1 degree is equal to 60 minutes, 90 degree is equal to 90 into 60 minutes, right? Those things will be able to calculate, simple unitary method, right? No problem in that. Okay, now next system, let's understand the next system, circular system. Circular systems in our hexadecimal system. In this system, if we talk about start moving, what happened to you? In this system, unit, what was your unit? Unit was degree. What was our unit? Unit was degree. So new system they were making, so they wanted a new unit also. So radian was the unit in circular system. What is the SI unit? SI unit, or unit to measure the angles here, is radian. Yeah, they were not convinced or influenced by the clock system, so they were like, no, we'll come up with something else. We are not very cool about it. Achha, how they came up with this idea? what they did is they made a few circles. I'm bad at drawing, so I'll try to keep it as good as possible. They made circles. They were just sitting idle and they were like, let's make circles. We'll practice for jalebis maybe, but yeah, they came up with circles. Okay, so they came up with circles, but by circles, what was the idea behind making these circles? They were actually observing one thing. They were like, okay, this particular radius, they said this is R, let's say radius. Okay, then this is an arc. This is arc, right? Length. So they call the length of this arc as L. Let me call this L1 and let me call these R1 and R2. Okay, ji. No, not R1 and R2. In fact, both will be same, R1 and R1, right? Why R2? Same radius. Okay, then they were like, okay, let's explore more. Let's call the bigger radius, the other radius as R2, and this particular length of arc they called as L2. Then they were like, let's not get satisfied by just two of them, let's make one more, and they made it here also. And this was, let's say, this arc length was L3. Okay, now we have radii also over here. This is R1, smaller one. Then let's call this one R2, and let's call this one R3. Okay, the outer one as R3. They observed one very beautiful thing and they were very happy. They even partied after it. Yeah, I know, like I'm very old. So what they observed was that this angle, this angle theta, angle is same only, no? Angle is same. It is just widening up, but angle is same. Angle is same only. It's going beyond, but angle is same. Angle mathematicians are fond of using theta. They liked this angle. They named it theta. Theta, and because previously also in trigonometry they were using theta only, they called the angle as theta. And they said, they observed that, Baba, L1 by R1 was equal to L2 by R2 was equal to L3 by R3. Oh wow, beautiful observation, right? Amazing observation. But what are they equal to? They are equal to theta. Huh? How? How can they be equal to theta? Theta is in degrees. They said no, it's not in degrees. This theta is in radian, and symbol for radian they used is C. Happy? Good? Cool? Getting it? Any problem? No. This angle they called it radian. This angle will be measured. This will also be a unit to measure angle, but this is not in degrees. This is in radian. What is in radian? Length of arc subtended by radii on angle theta, or length, right, at angle theta. Length of arc divided by radii will be the measure of an angle in radians, and that angle will be called as theta. Theta what? Radians. They called it radians. They were not degree. If it comes as 1, let's suppose, and yeah, one more most important thing I'll tell you. Let's suppose that for a unit circle, if we are talking, suppose if we are talking for a unit circle, suppose here we are talking for a unit circle. Unit circle means radii is 1, right? Unit circle, if we are talking, unit circle means radii is 1. So if in a unit circle, length of arc, when length of arc is 1 and the radii is also 1, that means L by R will come out to be 1, right? Arc of 1 unit subtended by a circle of radii 1 unit will be equal to 1 radian. This angle was 1 radian when length and radius both are 1 unit. Then they will subtend a 1 radian angle. Achha. Okay. Then, okay. Here only let's understand other thing. So how to measure other ones? Now how to know about other angles? Now how to know about the other angles, measure the other ones? What we'll do, We know that this is 90 degree. We know not 90 degree, let's call it right angle for now. Right angle. And this part, if I talk to you about this part, this particular part, this sector, there are 4 parts like a pizza, 4 parts. 1/4 part, total circumference is 2 pi r. Total circumference or total perimeter of this circle is 2 pi r. 1/4 of 2 pi r will be 2 pi r divided by 4. That means 2 pi r divided by 4. 1/4 part. Okay. Now, so we know this is right angle. Here right angle became right angle. What will be the value of right angle? Here according to this one, right angle will become 2 pi r by 2. That means 2 pi r by 4. That means pi r by 2. Pi r by 2. Divided by what? Angle. Angle we are measuring, no? So length of arc divided by radius. Radius is also r. So 2 pi r by 2 divided by r became pi by 2. That means right angle in radians. Right angle in radians is equal to pi by 2. You must have heard about this also, or must have seen somewhere in mathematics. Right? Right angle means pi by 2 what? Pi by 2 radians. Right angle is 90 degree and right angle is also pi by 2 radians. Right angle did not change. The theory behind it changed. Now we are calling it in radians. For example, temperature we can measure in Celsius and Fahrenheit. So many things we can measure in different units. So here also angles we are measuring in 2 different units. Simple thing to understand. Any problem? Clear? Hey yo, who's this? SRP. Hey yo. Nice. Okay. Right angle is equal to pi by 2 radians. That means, can we also say 90 degree is equal to pi by 2 radians? No problem, sir. Can we also say 180 degree? 180 degree means double of 90. 180 degree is equal to pi radians. Radian symbol, remember, okay? It's not degree, degree is this bindu. Understood till here? Pi by 2 radians means 90 degree, pi radians means 180 degree. 180 degree, pi radians, pi by 2, sorry, 90 degree. Okay? Yeah, right? And we can check also. Suppose this is our circle of radius r. This arc will be 2 pi r by 2, that means pi r. Now length of arc, theta in radians is length of arc, that means pi r by r, that means pi. So this theta will be equal to pi. 180 degree is equal to pi. Now everything is sorted. Don't worry about it. You will be able to, if you have understood this, you will be able to do the conversions, and conversion is also very important, right? Because here you see radians, the angle in radians is coming in numbers, right? Because length is number, radius is number. So while learning differentiation also we'll understand this, that we differentiate on real numbers. No? So we'll use radians, we'll use angles in radians, not in degrees there. If you are learning differential equations or differentiation right now, hello sir, please take my name. What is your name? Sachin. Okay, Sachin, I took your name. Now throw some likes and hits or something. What do I get? What do I get in return? Nothing. Okay. Anyway, let's see. Pi radians, simple sir. 180 degree. Straight line. 180 degree. Degree. Pi radians. Pi by 2. 90 degree, sir. No problem. Pi by 3. 180 by 3. 60 degree. 60 degree. Pi by 4. 180 by 4. 180 by 4, 45 degree. No problem. Because pi radians we have set, right? Pi radians is 180 degree. So 1 degree is, sorry, pi radians is 180 degree. So now we are just dividing this 180 degree only by 4 by 5 by 6. And pi by 6 is 30 degrees, sir. No problem. Okay. Here also one important note. Make a note of this. Pi value does not change. Don't think that the pi that we use in area and the one which we know as an irrational number, how is it? It has become 3.14. Pi has approximately taken as 3.14. Everybody knows, right? Pi is an irrational number. Sir, how many hours this lecture? I don't know. I'll try to. Hey, this just started. Just starting itself. See, guys, increase your attention time span. If we don't have a good attention time span, no, there is a serious problem, and this is because of watching reels all time. So watching reels decreases our attention time span. If we have started, wait for a while at least, right? What do we say? Ruko zara sabr karo, right? Okay. So pi means 3.14 only over here. Over here, pi means 3.14 only. 3.14 radians is equal to 180 degree. Okay, half of it means 1.57 radian is equal to 90 degree. No change in the value of pi. Okay. Okay. 1 radian into 180 by pi. Now, suppose I want to convert radian to degrees. Let's say 1 radian, I want to know 1 radian how much? 1 radian, I know 180 degree is equal to pi radian. Right, simple that. Unitary method we know, right? If 10 mangoes are taken for 50 rupees, then 1 mango will be equal to 50 by 10. That means 5 rupees. This we know. This we know from class 8th, 9th at least, right? So 180 degree is equal to pi radian. 1 radian is equal to 180 by pi degrees. 1 radian is equal to 180 by pi degrees. 180 divided by 3.14 it will be. That was only written. 180 divided by 3.14 will come out to be 57.296 degrees. So 1 radian is equal to 57.296 degrees. Although we won't get to use this and we'll be able to calculate also, but still, remember this. Okay. So can you tell me where will 1 radian be in 4 quadrants? If I divide the circle into 4 quadrants, let's say this is my y, this is my x, okay, this is my negative x, this is my negative y. Now can you tell me 1 radian will be in which quadrant? 1 radian will be in, we know, right, this is 90 degrees. In degrees to at least we know, right? 1 radian means 57.296 degrees. So 57.296 means less than 90. So 1 radian will be in the first quadrant. 2 radian, 2 into this will be definitely more than 90 but less than 180, right? 2 into this approximately you can do 114 point something, so second. 3 radian, this quadrant. 4 radian, this quadrant. It will keep going on. Now the angle don't stop. Now it's not specific only to 360 degrees. We'll go beyond 360 degrees. So yeah, simple, obviously, right? Why are we not knowing about more than 360 degrees? I rotated myself 1 time. So I rotated myself for 360 degrees. If I rotated myself 2 times, so I rotated myself for 720 degrees. No, logically it should be correct. So we have to go beyond 360 degree also. There is no limit. There is no limit. Okay. Next thing. Convert the following into radians. 480 degree, 420 degree. We see in maths, very simple or very basic thing to do always is two important things about math, I would say. First, be a fighter. Be a fighter. Don't be like little difficult problem or something. You saw some calculation and you are like, I don't like maths. I'm going away from maths. Let's keep math aside. No. Second thing, you have to start with what you know. Obviously, you have to know a lot. You have to know the concept at least. But whenever you see a question in mathematics, no, at least start. We'll follow this for the entire session. So I'm telling you already, at least start with what you know. What do you know? I know, sir, 180 degrees is equal to pi radians. Then I know, sir, unitary method, 1 degree is equal to pi by 180 radians. Okay, sir. Then I know 420 degree. 1 degree is this. Then 420 degree will be equal to pi by 180 into 420. Now I know cancellation. So I can calculate this. I'm not going to calculate, okay? I'm very lazy in maths. So And don't you think math should be a subject of lazy people? I believe that math should be a subject of lazy people only. Lazy people can be good or better at math because they'll explore of tricks and methods and shortcuts and all the time. They don't want to write so much. So yeah, okay. Next, 10 degree 30 minutes. Acha, 30 minutes. 30 minutes came. 10 degree 30 minutes. I know that 1 degree is equal to, what do I know? 1 degree is equal to 60 minutes. I know this relation. Sir, 1 degree is equal to 60 minutes. Everybody knows this or not? Yes or no? Everybody knows this or not? 1 degree is equal to 60 minutes. So 1 minute is equal to 1 by 60 degree. 30 minutes is equal to 30 by 60 degree. 30 by 60 degrees. Right? So this is half degree. 30 by 60, 1 by 2. 1 minute is equal to 30 minutes is equal to half degree. Okay, so no problem, sir. Then what? Now I can do 10 degree plus half degree. 10 degree plus half degree. Now I can solve, either add it up because now they are in the same unit, or just do like this. 1 degree is equal to pi by 180, so 10 degree is equal to 10 pi by 180 radians. Half degree will be equal to half into pi by 180 radians. That's it. In radians you can convert every time. Unitary method. Here the trick or the catch is unitary method, and some calculations will be there. Some basic calculations will be there. Right? Pi by 18, and here we'll get pi by 360. Add them up. Now you can add. Same unit. Let's move ahead. Let's see some more things. So this will come out to be 7 pi by 3. And this has come out to be 10.5 into directly 10.5 also you can do 7 pi by 120. This will come. So conversion, now everybody must be clear, no problem. Conversion is definitely very important. Let's go from radian to degree. Let's go from radian to degree. Give it a try for a minute. Give it a try. Come on, do it yourself. Okay, use your pen, paper, power, brain, everything. Oh my God. Sorry. I have to keep my throat intact for some few hours at least. What do I know? I know, sir, pi radians is equal to 180 degree. Where do I want to go? I want to convert radian to degrees. So I'll say, okay, 1 radian is equal to 180 degree by pi. 180 by pi degree actually. 180 by pi degree. 1 radian is equal to 180 by pi degree. So I want to convert minus 2 pi by 3. Minus 2 pi by 3. Okay. Minus 2 pi by 3 radians will be equal to 180 by pi multiplied with minus 2 pi by 3. Now what? Maths. 7th class maths. Cancel. 60 minus 120 degree. Okay, can you convert the others? I'll do the fourth one. I know 1 radian is equal to 180 degree, 180 by pi degree. Now 1 radian, here pi got cancelled. Here pi got cancelled. There also, in radians there is no pi, so pi value we'll have to put. Just remember, you can choose anything. 22 by 7 is also fine, 3.14 is also fine. We know the value of pi, right? So 1 radian will be equal to 180 by pi. 180 by pi, now 1 by 4 radians, that means this thing only we have to multiply with 1 by 4. Okay, sir. Pi I can put as 22 by 7. So this will become 22 into 180 divided by 7 into 4 degrees. This will be for 1 by 4 radians. This also you can convert. This also you can convert. This will become 180 by pi into pi by 10, 18 degree. This will become pi by 24 into 180 by pi. Okay, check. Acha, here when we'll convert it into radians, degrees, no? When we'll convert into degrees, sometimes in options it is possible that you will get to see your answers in minutes and seconds. So if you are getting a mixed fraction, for example, over here we are getting a mixed fraction, 14 degrees 7 by 22 into 60 minutes. First, we'll convert this 7 by 22 into 60 minutes. Then again we are getting a mixed fraction, 19 1 by 11. So now 1 by 11 will convert into seconds by multiplying to 60, right? See, here 14 7 by 22. After solving this, 1 by 4 into 180 by 22 into 7, right, 1 by 4 into 180 by 22 into 7, we are getting 14 7 by 22. So 14 is complete degrees, mixed fraction. 14 7 by 22 means 14 plus this 14 7 by 22 means nothing but 14 plus 7 by 22. Okay, now 14 is degrees, but what about 7 by 22? We want a proper answer. Maybe in options you don't have this one, you have this one. So you have to check. That means they have converted the mixed fraction part into the minutes and degrees, minutes and seconds. So 7 by 22, we know 1 degree is equal to 60 minutes. 7 by 22 degree is equal to, this means 14 degree plus 7 by 22 degrees. So 7 by 22 degrees means 7 by 22 into 60. This will be in minutes. Now again we got 19 1 by 11 on solving this. So 14 degrees, 19 minutes. And 1 by 11 into 60 seconds. 1 by 11 into 60, approximately 5 you will get. Don't have to get into that much of calculation. We already noted this down. Keep making notes, short notes. Maybe you can keep 5 to 7 pages with you. At least whatever I'm asking you to note, keep a note of them. Because for this chapter, memory is going to play a vital role here. Memory, we have to remember things, because calculation we have to speed up. We don't have the entire day for any competitive exam, max 3 hours for one paper. Okay, that too in maths even lesser time, but all 3 subjects if you'll get. Acha, this also we know, right? And 1 degree, sometimes they might ask you which quadrant, or they might use this information that 2 radian is going to be in second quadrant, 3 radian in 3 radian will be in second quadrant, 5 radian will be in fourth quadrant. These type of questions they might ask you. Okay, these type of questions they might directly ask you. Keep a note of these things. Okay, cool. Four radian actually, also 4 radian 4 radian 57 point something into 4 if we'll do, we'll get somewhere around 231.14, 231. So here, see, again, let me come to that circle again. Yeah, here. This is x, this is y. We know this is 0. Now this angle 90 degree, that means here this will be pi by 2, right? 90 degree, this angle will be pi by 2. Here we'll have a pi by 2. This one, that means pi. This one over here means this much will be pi by 2. Then this much will be pi. This one, pi plus pi by 2. That means 3 pi by 2. Right? So in first quadrant will be between 0 to pi by 2. Second quadrant, pi by 2 to pi. Third quadrant, pi to 3 pi by 2. That means this is 90 degree. Then 90 to 180, 180 to 270. 90 into 3. 270, and this is 360, right? So that's why 1 radian will be here, 2 radian will be here, then I think 3 and 4 both will be over here. Calculate 57.296 into 3, 171, 171, 171 will be here only, right? Then into 4 if you will do, that's how you have to find out. 5 radian will come over here. 5 radian will come over here. Are we all clear? Everybody clear? Any problem? 4 radian will be in third quadrant. Yes, very good. Who was this? Nikhil. Nikhil is constantly understanding and replying. Very good. Good spirit. Those who will be able to attend the entire session, right? For entire session in one sitting, no? Maybe a short break if we'll get time. Commendable. Literally commendable. That proves that you are dedicated for your goal. Because attention, it is all about your attention time span. It is definitely all about your attention time span. L is equal to r theta. Just now we learned, no, theta in radians is equal to L by r. So L is equal to r theta. Correct? L is equal to r theta. Right? The minute hand of a watch. Simple questions, some related to this, although not for competition, not for our JEE, but we should know this. Maybe this type of calculation is required somewhere. This formula's practice. Can you give me the answer in chat box? Let's see who can give me an answer in less than 30 seconds. Come on. In 40 minutes, how far tip moves in 40 minutes? So in 1 minute, in 60 minutes, the tip is going to rotate for 360 degrees, correct or not? Minute hand, the longer one. In 60 minutes, it will rotate for 360 degrees. In 1 minute, it will rotate for 360 by 60. That means 6 degrees. In 1 minute. In 40 minutes, how much it will rotate? It will rotate 6 into 40. That means 240 degrees. Right? 240 degrees means 240 degrees. Let me check the chat box. 4th radian. No answers yet. Come on. L is equal to R. Just think about theta is equal to L by R or L is equal to R theta. L is equal to R theta. Come on. 6.28 centimeter. Minute hand will move 6 degrees. 6 degrees. Now convert. L is equal to R theta will be applied in radians. Convert. First we'll, because in L is equal to R theta, theta is in radians. So you have to convert your theta. That means 6 degree into radians. How will we convert? By multiplying it to pi by 180. Clear everybody? In 1 minute, in 1 minute, how much it is moving? Pi by 30 radians. In 40 minutes, it will move 40 into pi by 30 radians. That means 4 pi by 3 radians. Now just apply L is equal to R theta. 1.5 into 4 pi by 3. That means 6.28. Clear everybody? Shall I explain? 4 quadrant will be the third. Keep replying. In a circle of diameter 50 centimeter, a chord of length 25 centimeter is taken. Find the length of the minor arc corresponding to the chord. Can we do this? What do we need to do? Length, okay, number, no problem. Length is a number. Angle you have to find. Chord is 25 centimeter. That means something like this. That in a circle of diameter 25, diameter 50, that means radius 25, can I say? 25, a chord of length 25. Chord of length 25 is taken. Find the length of minor arc corresponding to the chord. What do we need to find? We need to find this length. Can you give me an answer? Anybody? People are not interested only, I think. No, sir. Think about it. No, 25, 25, 25. What is it? It is a choco pie. Choco pie means it is 60 degree equilateral triangle. All three sides are equal. What do we need? We needed this only. We needed 60 degrees only. We need theta only. Theta is equal to 60 degrees. In radians, pi by 180 into 60. That means pi by 3. Pi by 3 radians. Okay. Theta we got. Length of arc we want to know. That's what, right? Length of minor arc we want to know. What is R? R also we have. R is 25. Shall I not use pink color? Okay, no problem. Now clear? Now clear, right? R is equal to 25. Now just apply. L is equal to R theta. Okay, L is equal to R theta, you have to apply. L is equal to R theta means 25 into pi by 3. If in options you have answer with numbers, no pi, then put the value of pi as 22 by 7. Okay, otherwise leave it like this. 25 pi by 3. Pi by 3 approximation 26.16. 3.14 you can use. 22 by 7 I prefer more of the times, because eventually you have to cancel and then find the decimal, right? Somewhere around 26.16. All cool? The only catch was over here is theta is equal to 60 degree. Let's move ahead quickly. This category is also, you know, maybe not, we have not seen any too many questions or very repeated questions on this category in JEE mains also now. But yeah, this can be used. This can be used in some other question or somewhere. Angle between the minute hand and hour hand. And if you'll see the aptitude or those questions, no quants questions, this category is definitely going to be there. Angle between hour hand and minute hand. Achha. About minute hand, if we see, in 60 minutes, the minute hand, we are talking about minute hand, right? In 60 minutes, the minute hand is going to travel 360 degrees. So we know in 1 minute it is going to travel 360 by 60, that means 6 degrees. This we need to know first. How many degrees will the hour hand move in 1 minute? Can you tell me? Come on. How much will the hour hand move in 1 minute? How many degrees will the hour hand move in 1 minute? The hour hand moves in 12 hours. 12 hours means 12 into 60, 720. Right? Hour hand completes one complete round in from 12 to 12. That means 12 hours. 12 hours means 12 into 60. If we convert in minutes, in 12 into 60, 720 minutes. In 720 minutes, the hour hand will rotate for 360 degrees. Right? I'm writing for hour hand. In 720 minutes, it will rotate for 360 degrees. That means in 1 minute, it will rotate for 360 by 720. That means 1 by 2 degrees. This also we need to know. This is for hour hand. This is for minute hand. Okay. Now we'll be able to solve these questions. Hour hand travels half degree. That is 30 minutes in 1 minute. Okay. Not a problem. I'll also tell you a trick to solve these questions, but first let's understand by the method only. Find the angle between the hour hand and the minute hand at 130. 130. 130 means where will be our hand? Sir, first let's talk about minute hand. Minute hand will be at 6, right? For sure. Minute hand will be at 6. Pakka. Where will be hour hand? At 1? No, it won't be at 1. It will be slightly between 1 and 2. Right? It will be between 1 and 2. It will be somewhere over here. It has shifted, right? It is supposed to be at 1 because it's 1 o'clock, but it has obviously, right? 1:30 now. So somewhere ahead of 1. Okay. Now, between any two numbers, if I talk about this angle, how much will this be? Complete 360, 12 parts of 360 are there. 12 parts of 360 are there. So 360 by 12, that means this will be 30 degree. This will be 30 degree. No problem. Between 1 to 6, how many degrees? 1 to 6, 30, 30, 60, 30, 90, 30, 120, 150. 150 degrees totally. Between this is 150 degrees. Okay. 150 degrees. And our hand has shifted. if our hand was at 1 and minute hand has to be at 6 only. If it was the case, then 150 degrees will be the total angle. Why? Because 30 into 5, 150 degrees will be the angle. Now, but our hand has shifted. How much has our hand shifted? Our hand shifts in 1 minute. Our hand shifts for half degree. How many minutes have passed? How many minutes have passed? Sir, 30 minutes have passed. 30 minutes have passed. So 30 minutes, how much will it rotate? Half of 30, that means 15 degrees. 15 degrees. That means 150 minus 15. Right? 150 minus 15. This rotation is 15 degrees. So 150 minus 15. Our angle will be 150 minus 15, that is 135 degrees. This will be the angle. If we talk about 240, if we are talking about 240, that means this 240 means minute hand will be over here at 8 and our hand will be somewhere between 2 and 3. Somewhere between 2 and 3. Where what is it supposed to be? It was supposed to be over here, but it has shifted. Okay. What should be the angle? 1, 2, originally if our hand was at 2, 1, 2, 3, 4, 5, 6, 6 into 30. That means 180 degrees should have been the angle, right? The angle, this angle should have been 180 degrees. But what happened? Our hand moved a little. Our hand moved a little bit ahead. So 100 degrees, sir, 135. Nikhil, how? Acha, second one you are telling. Very good, Nikhil. Our hand has shifted. Okay, our hand has shifted. Our hand has shifted how much? Sir, 40 minutes. So in 40 minutes, our hand will shift for 40 into 1 by 2 degrees. Every minute it is moving. So it is going to shift for 20 degrees. Okay. It is going to shift for, that means this much will be of 20 degrees. So total angle 180 minus 20, that means 160 degrees. Nikhil, how 100? Find that 130. Acha, 130 we did. 240 also we did. Acha, trick I didn't tell. Trick is, write it down, 30h minus 11 by 2m. Whichever comes positive, that will be your answer. H means R. M means minute. M means minute. That means over here, 30 into 1 minus 11 by 2 into 30. Okay. 1 means R's value. What is the value of R here? 1. Minutes value is 30. What are we getting? 30 minus 11 into 15, 165. 135 only. Positive you have to take. Okay, positive only you have to take. It is coming negative. So if it is coming negative, just reverse the formula. 11 by 2m minus 30h you can do. Whatever gives you positive, use that. So this will be 135 degrees. Okay. For what was the other angle? 240, right? So 30h minus 11 by 2m. Right? 30 into 2. H is 2. 2 hours minus 11 by 2 into 40. 40 minutes. So 220. So it will be 60 minus 11 into 20. 220. 160. Positive only you have to take. Okay, you can put mod here. If you understand mod you can use. 160. Okay. Clear everybody? Nikhil? Okay, now he's clear. Good. Cos theta, sin theta's revolution. Let's revise cos theta, sin. Now we'll define cos theta, sin theta differently according to circular system. Because sin theta, cos theta is not only defined for 0 to 90 degrees. Definitely not. So far we have studied, if you are in class 12, then you know this. But if you are studying this for the first time, you'll understand that it's not only about 0 to 90 degrees now. Trigonometry is not only specific to 0 to 90 degrees. It is much more than that. So now, according to circular system, how will we define cos theta, sin theta? Listen to this very carefully. If we'll understand this, we'll not have to mug up a lot of things. Otherwise, on odd functions, on even function, when there is an odd quadrant, or the angle's value is coming out to be in odd form, even form, so many confusion. If we can understand the theory of it, we'll be able to understand the sign of trigonometric functions. That is going to matter a lot. Okay, ready everybody? Shall we go? Shall we go? Keep replying. Any angle? Yes, yes, Prathan. Any angle we can define it for any type of angle. Great. So how? Question is how? Very simple to understand. Actually, what? This is a unit circle. First of all, we are defining everything for a unit circle. Unit circle means radius equal to 1. Now we are defining everything, we are talking about everything for defining in the unit circle, in a unit circle, right? Radii equal to 1, that means this is 1, this is 1. That means this point is going to be, if this is 0, 0, can you tell me this point? X is 1, Y is 0, right? Unit circle, no? Radii is 1. This is X is 0, Y is 1. Here X is minus 1, Y is 0, and here X is 0, Y is minus 1. Correct? Right? What we are trying to say, that any point on this unit circle, any point on this unit circle, here the coordinates, listen to this carefully, here the coordinates will be defined as cos theta will be taken as X coordinate, sin theta will be taken as Y coordinate. Now we are defining the cos theta and sin theta as coordinates here. Just understand this. Things will go easy for you. Okay. Cos theta, sin theta, we are talking about angles now. Okay, sir. Okay, no problem. And you can remember this. See, cos theta. That means cos 0. What is cos 0? 1. Right? So, X coordinate cos theta. Y coordinate cos. Sin theta. That means sin 90 is 1. So, sin theta is 1 here. The coordinate will be 1. And over here at 0 degree, cos 0 degree, if we are talking about this is an angle, right? This is theta. For 0 degree, my cos 0 will be 1. So, X coordinate cos theta. For 90 degrees, my sin theta will be 1. So, Y coordinate is sin theta. Remember this, X coordinate, you can write like this, X coordinate as cos theta over here, Y coordinate as sin theta. This will help you a lot in understanding the sign while taking the angles. This is going to help you a lot. Are we clear, everybody? Shall we move ahead? Sir, watching live from Allen, Bangalore Center. Wow, great. Thank you. Okay. Now, theta. Understood? What did we understand, sir? This is cos theta, sin theta. This is cos theta, sin theta. Okay, ji, no problem. Now, in first quadrant, if we talk about first quadrant, did we understand how are we defining cos theta and sin theta now? In the circular system, in a unit circle, we are defining cos theta, sin theta. Now, if we talk about quadrants, okay, this is already defined here. Now, let's talk about quadrants. Now, let's see where all they'll be positive or negative. Cos theta and sin theta. Okay, sir. First quadrant, X is positive, Y is positive. Cos theta, sin theta, both positive. Can we say that? Cos theta, sin theta, both will be positive in first quadrant. Yes, sir. No problem. Acha, one more thing you have to know here. This is pi by 2, right? This is pi. This is 3 pi by 2. Why? Pi by 2 plus pi. Pi by 2 plus pi. Pi means 180 degrees. So, pi by 2 plus pi, 3 pi by 2. Correct? Pi by 2 plus pi, 3 pi by 2. Then again 3 pi by 2 plus pi, 3 pi by 2 plus pi by 2. This is pi by 2. So here we'll get 2 pi. Again if we'll rotate more, 2 pi plus pi by 2 then. right? 5 pi by 2. Again, if we'll rotate more, like that, it will keep going on. So in first quadrant, that means between 0 to pi by 2, cos theta is positive, sin theta is positive. Cos is positive, so sec theta will be positive. Sin theta is positive, so cosec theta will be positive, and tan will be positive only, my friends. Why? Because sin theta by cos theta is tan, so tan will also be positive. So in first one, we say that all ratios will be positive. Cos theta, sin theta, tan theta, sec theta, cosec theta, cot theta, everything will be positive. Second quadrant, can you think on your own now? That means between pi by 2 to pi, when the angle is between pi by 2 to pi, that means suppose this is the angle. Angle how will we take? Remember, angle this anti-clockwise, okay, forgot to tell you. Anti-clockwise angle will be positive. Clockwise will be negative. So you have to take angle anti-clockwise. If there is an angle negative, suppose if I am saying sine of minus pi by 4, that means I am talking from this side, right? I am measuring angle from this side. Anti-clockwise will be positive. So this is going to be my angle. Suppose my angle is between pi by 2 or pi by 2 plus pi by 4, let's say, then will be here, and in this case, what all will be positive? X coordinate will be negative. That means cos theta is going to be negative. Y coordinate is positive, so sin theta is positive. Tan theta is sin theta by cos theta. Tan theta will be also negative because cos is negative, sin is positive, so division will be negative. Cot will be negative. Cosec will be positive because sin is positive. Sec will be negative because cos is negative. Okay, fourth quadrant, let's look over here. This is exactly image, right? So here cos theta is negative, sin theta is negative. Cos theta means x coordinate negative, sin theta means y coordinate negative, cos theta, sin theta both negative. So tan theta will become positive. Why? Sin theta by cos theta. Negative, negative cancel. So positive, right? Here, over here, sir, x coordinate positive, cos theta positive. Sir, sin y coordinate negative, sin theta negative. Tan theta will be negative. Why? Because sir, sin theta is negative, cos theta is positive, so tan theta will be negative. Rest of them you can find on your own now. This idea of understanding the concept, are we clear to understand? Are we understanding? Are we able to understand? Are we able to understand? Judging the sign, very important. Okay, this is how, if we'll think, no, we'll never do a mistake in choosing the sign of our trigonometric function in sine, cos, tan, any angle. Don't worry about it, right? Many things it will help just by this. Remember, cos theta x coordinate, sin theta y coordinate. Where will they be negative? Which quadrants? X coordinates are negative. Which quadrant? Y coordinate is negative. Okay. Okay. Acha, that we can say, right? Always sin theta. Sin theta is unit circle. We are defining it for unit circle. In unit circle, maximum sin theta. Maximum sin theta can be 1. Right? Maximum sin theta can be 1 and minimum it can be -1. Cos theta also maximum 1, sin theta cos minimum -1. Okay, sin theta is maximum 1, minimum -1. Always, right? Equal to, less than equal to. Clearly, cos theta and sin theta both, this same applies for cos theta also. Sin theta I have written, I was saying cos theta. What happened to me? I don't know. Okay. Clearly, cos theta and sin theta are defined for all angles and not only for acute angles. Now, can you believe me? Now, can you believe me? Hi. Hi, Dalal. How are you? Hello. Observations. What is our observation? Sir, observation, first of all, remember where all, what all will be positive. Where all, what all will be positive. In the first quadrant. In the first quadrant. First quadrant. That means 0 degree to pi by 2. 0 to pi by 2. X positive, Y positive. That means sin theta positive, cos theta positive, tan theta positive, and remaining rest of them you can find, right? Same signs for their reciprocals also, cosec, sec and cot, right? Here sin theta positive. What else? Cos theta negative. So I'll write the signs later. Wait. Cos theta, tan theta. Second quadrant. Third quadrant, cos theta, sin theta, tan theta. Remember this, okay? Very important. Cos theta, sin theta, tan theta. No problem. Let's write the signs. Okay, here all the three are positive. Here sin theta is positive. Cos theta negative. X coordinate means cos theta negative. Cos theta is x coordinate, so left side negative. Tan theta sin by cos, this will also come negative. Cos theta in third quadrant. In third quadrant, that means between pi and 3 pi by 2. Between here it was between pi by 2 and pi, and here between pi and 3 pi by 2. Cos theta will be negative. Sin theta, y coordinate negative. Tan theta will become positive because these two are negative. So tan theta is sin theta by cos theta, it will become positive. In fourth quadrant, cos theta, x coordinate positive. Sin theta, y coordinate negative. Tan theta, positive by negative, negative. Are we clear? I hope all of us are clear. Now look, let's look like this. Sin theta 2n pi, that means this, listen now, this is 0, right? When we'll have one rotation, this will become 360. 360 means 180 into 2, that means pi into 2, that means 2 pi. Then again when we'll come here, after completing 2 pi, one more round if I take, I'll have 4 pi, 2 pi plus 2 pi, correct? Then 6 pi and so on, right? Here, look here, look here. Now about this one, this point. This is from here to here. If I move from here to here, pi. This will come at pi. Now from pi, one more complete round. Suppose if I take from pi one more complete round, that means pi plus 2 pi. So where will I come at? 3 pi. 3 pi plus 2 pi, 5 pi. 7 pi. Correct? Now look here. This is pi by 2. Okay? Pi by 2. Pi by 2 plus 2 pi. 5 pi by 2. 5 by 2 pi, 5 pi by 2 plus 2 pi. 9 pi by 2. Okay? Okay. Now, over here, this one. This is pi by 2 plus pi, that means starting 3 pi by 2. 3 pi by 2, one complete round again I'll come at, after first time I'll come at 3 pi by 2, then again one round if I take from 3 pi by 2 only, then 3 pi by 2 plus 2 pi. So 7 pi by 2. 3 pi by 2 plus 2 pi. 7 pi by 2. 7 pi by 2 plus 2 pi. Now you'll keep going on like that, right? You understood my idea. Which angles are coming back here? 7 pi by 2 plus 2 pi. Keep telling me in the comment section. Okay, now look. Cos 2n pi. 2n pi means here 2 pi. 2n pi. n0 that means 0. n1 that means 2 pi. n2 means 4 pi. n3 means 6 pi. What will be cos? When cos will be here? Cos means x coordinate. Cos is always 1. X coordinate is always 1 at 0, 2 pi, 4 pi, 6 pi. That means cos 2n pi will be 1. Can I say that? Can I say that? Now, cos 2n plus 1 pi. 2n plus 1. That means n0. Let's start from 0. n0 that means cos pi. n0 means pi. 2n will become 0. Cos pi. Cos pi is minus 1. Cos is x coordinate. So, minus 1. Cos pi is minus 1. So this is minus 1. Then put n as 1. 2 into 1 plus 1, 3 pi. Cos 3 pi is also minus 1. Then put n as 2. 2 to the 4. 4 plus 1, 5. Cos 5 pi is also minus 1. So whenever we have in the form, angle in the form 2n plus 1 pi, even angle with cos will always give us 1. And odd angle with cos will give us minus 1. Can we say that? Can we say that? Sin n pi. N pi. 0 means sin 0. Pi means sin pi. N1 means n is equal to 1 means sin pi. Right? N is equal to 2 means 2 pi. So look at sine. When sine at 0 is 0. Sine at pi is also 0. Sine at 2 pi is also 0. Sine at 3 pi is also. Sine is y coordinate. Y coordinate is 0 at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. Sin n pi is coming out to be 0 in any case. Where? It is in the form of n pi. N can be 0, 1, 2, 3, any natural number. Now sine. Now let's talk about these. Sine 4n plus 1 pi by 2. 4n plus 1 pi by 2, sir. 4n plus 1. n0, that means sine pi by, n0, that means sine pi by 2. Sine pi by 2 is y coordinate, 1. Sine pi by 2 is 1. Then n is equal to 1. So 4 into 1 plus 1, 5 pi by 2. N is equal to 2. 4 into 2 plus 1, 8 plus 1, 9 pi by 2. What is sine if the angle is in this form? 4n plus 1 pi by 2, it is always coming out to be positive 1, which is the y coordinate. Sine is y coordinate, right? So 1. Okay. Sine 4n plus 3. 4n plus 3. n0, that means 3 pi by 2. n1, that means 7 pi by 2. n2, that means 4 2s are 8. 8 plus 3, 11. 11 pi by 2. Yeah, this. Okay. Still not. 11 pi by 2. You have understood from here. Okay. So sine at 4n plus 3 pi by 2 will be minus 1. Can I say that? Minus 1. Cos at 2n plus 1 pi by 2. 2n plus 1 pi by 2. n0, that means pi by 2. n0, that means pi by 2. n1, that means n1, that means 3 pi by 2. Okay. n2 means 5 pi by 2 here. n3 means 7 pi by 2 here. n4 means 9 pi by 2 here. What is cos? Cos is 0 in either of the cases. Cos is 0. Cos is x coordinate, right? On y axis x coordinate will be 0 only, sir. So this is always going to be 0. Cos of minus theta. Now let's understand what do we mean by cos of minus theta. Cos of minus theta. Minus theta, what did I say? What did I say about minus theta? How will we have minus theta? That means negative angle. That means we are measuring from clockwise side. That means we are talking about, if this is theta, then this is minus theta. Do I have another circle here? Here I have, right? So if I'm talking about this is, let's say I'm taking theta. Suppose if I'm taking this particular thing as theta, then this is my minus theta. Okay, anti-clockwise direction. Anti-clockwise. This is clockwise. So positive theta. Now sine of theta. Sine of, no, not sine of theta. Sine of minus theta. They are talking sine of negative angle. Sine of minus theta will be what? Minus theta, that means this side, fourth quadrant. In fourth quadrant, sine is negative. So it will come out to be minus sine theta. Cos of minus theta. Okay, cos of minus theta. Cos of the minus theta means fourth quadrant. Minus theta means fourth quadrant. This side. That means cos is positive x coordinate, right? In fourth quadrant, cos is going to be positive. Cos is x coordinate. So minus won't matter for cos, and cos will gulp down the minus sign. It will come out to be cos theta only. Understood? Not understood? Understood? Not understood? Tell me. watching live from, oh my god, people are watching from different places. Great. Great. Thank you. Thank you so much. Are we clear about sine of minus theta and cos of minus theta? Sine of minus theta, cos of minus theta, cos theta only, no problem. Let's, cos theta is 5 by 13 and theta lies in 4th quadrant. Then find the values of sine theta and cot theta. Cos theta is 5 by 13. Cos theta we know is base by hypotenuse. So 5 is base, hypotenuse is 5 is base, hypotenuse is 13. That means perpendicular is going to be 12. So what will be my sine theta? Sine theta will be 12, perpendicular upon hypotenuse, 12 by 13. And what will be my cot theta? Cot theta will be base upon perpendicular, reciprocal of tan. So base upon perpendicular, that means 5 by 12. Right? But sine, now we have to check the sign. In 4th quadrant, sine is negative. So we'll put a negative sign. In 4th quadrant, cot or sine is negative, cos is positive, cot will be negative only. So put a negative sign. That's it. These will be the correct values. In 4th quadrant, sine theta cannot be positive. It will be negative only. And cot theta applies the same applies for cot theta also. Okay ji? Now clear? Wow, simple question. 2024 only. Really? Yes. Okay. Sin x is minus 3 by 5. Theta lies between pi to 3 pi by 2. Where? That means theta is lying between pi. This is pi. This is 3 pi by 2. That means theta is lying in 3rd quadrant. In 3rd quadrant, sin is negative, cos is negative, tan is positive. Right? So yes, we can see that sine is negative. Sine is negative. So sine means minus 3 by 5. Sin x, it means minus 3 by 5. What will be cos x? Can you tell me? Can you tell me cos x? Cos x, sir, will be p by h. So b by h. That means, 3 by 5 it is. Wait. 3 by 5, sorry, 3 by 5. So it will become 4 by 5. Cos is in 3rd quadrant, cos also negative, sir. No problem. Sir, tan x, what will be tan x? Tan x will be sin x by cos x, 3 by 5, minus 3 by 5 upon minus 4 by 5, and it is coming out to be positive also. It will be 3 by 4, sir. No problem, sir. Now look at this. 80 tan square x, that means 80. Here it's just about sine. In this question, there is nothing major to do. Yeah, sometimes JEE people also become very generous and give these questions. But here also people make mistakes in sine. Sine matters, right? From now on, trigonometry, for entire trigonometry, the sine will matter for all of us. So do not mess up with the sine. Don't do that mistake. So 80 multiplied with tan square x, tan square x is going to become 9 by 16 minus cos x. Cos x will become minus 4 by 5. So this will become plus 4 by 5. Okay, just start this. Solve this and you got your answer. This looks like 80, right? 80. This is 80. 80 into 9 by 16 plus 4 by 5. 45 plus 64 by 16 into 5. Somehow. Correct answer we have is 109. 9 by 16 plus 4 by 5 means we are getting 45 into 64. This 80 must be getting cancelled. 109 is our correct answer. Look here. 109 hai? Yeah, we have this. Okay. What did we have to pay attention over here? Where does the angle, where is the angle? Angle is in 3rd quadrant. So what all is positive, what all is negative? How to remember that? No need to mug up. You can remember simply by imagining the quadrant. Imagine the quadrant in your head. Eventually with practice, you won't have to do that also. With practice, eventually you won't have to always imagine. So like, sir, how much will you imagine? You do some 10-15 questions of the same type in this scenario. You won't have to actually imagine. Your brain will start processing it automatically. 2 cos theta plus sin theta is equal to 1. Then find sin theta, cos theta, tan theta, where theta lies in 4th quadrant. Here pay attention at this thing, 4th quadrant. How will we solve this? Any ideas? How will we solve this? 2 cos theta is plus sin theta is equal to 1. Can we say, sir, 2 cos theta is equal to 1 minus sin theta? Okay. Okay. 1 minus sin theta. See, I told you, right, in maths you have to start with what you know. Right now, sir, we don't know anything. 2 cos theta plus sin theta is equal to 1. And they are asking about sin theta, cos theta, tan theta. What can we do? We know that if we make an equation in sin theta, we'll be able to process the value. So let's make an equation. What can I do? Square both the sides. Best thing. Square both the sides. 4 cos square theta is equal to 1 plus sin square theta minus 2 sin theta. Now it is visible that I can create an equation in sine. So what will I do? I'll do 4 into 1 minus sine square theta is equal to 1 plus sine square theta minus 2 sine theta. Correct or not correct? Tell me. Correct. Now equation, quadratic equation in sine, right? No problem, sir. 4 minus 4 sine square theta is equal to 1 plus sine square theta minus 2 sine theta we are getting. Sir, why am I writing sine in two different styles? Even I don't know. Okay, so what will we have? Sine square theta plus sine square theta will become 5 sine square theta. Minus 2 sine theta will remain as it is. Minus 2 sine theta. 1 minus 4 will become minus 3. Is equal to 0. This is of the type, if I take sine theta as t, if I take sine theta is equal to t, this is nothing but t square minus 2t minus 3. I know how to factorize this. Do I know? Right? Let's factorize this. T square plus t minus 3t. Product should be 3, sum should be minus 2. So product should be minus 3, sum should be minus 2. Minus 3. T plus 1 minus 3. T plus 1. T plus 1 and t minus 3 is equal to 0. That means t can be 1 or t can be minus 3. What does this mean, sir? This means that my sine theta can be 1 or sine theta can be minus 3. Sir, which one to choose? Which one to choose? Information is given over here. 4th quadrant. Bhaiya, 4th quadrant. 4th quadrant. Inside 4th quadrant, my sine theta will be negative. Sine theta y coordinate. Sine theta y coordinate and y coordinate in 4th quadrant is negative. Simply remember like this. So which value is correct? This value is correct. Okay. Similarly, now you can do cos theta and tan theta, right? If you have sine theta. Any problem? Any problem? Anybody? The one who are watching it live, keep a pen, paper, everything ready, set with you. Those who are going to watch as a recording, still treat it as a live. Okay. Next thing, allied angles. Allied angles. Allied angles itself, the name suggests, right? No, name doesn't suggest. What does the name suggest? Allies. Allies. We know what allies means, right? Allies. Life. Bond. Some relation, some bond is there, something is connected, some connection is there in allies. So yes, different. The angles which have some connection between them, which can be correlated, are called allied angles. Nothing to define about it. How do we define? If you want to define theta and n pi plus or minus theta, this type of angles. Theta and pi, 30 and pi minus 30. You have studied about complementary angles, theta 90 minus theta. If you have, I don't know, it's not there in syllabus of CBSE nowadays. But if you have, then those complementary are also allied angles. So pi plus theta, pi minus theta, these type of angles again are of this type. Theta, n pi plus theta, n pi minus theta. For example, 30 degree, 3 pi plus 30 degree, 3 pi minus 30 degree, allied angles. So angles of this type are going to be called as allied angles. Why are we calling it allied? Because this is theta. If this is also theta, we are taking angle from anti-clockwise. So this is theta. How much this will be? This will be pi minus theta. Both are equal, no? Pi, complete pi minus this part. This is theta only. So pi, if these two are equal, if this is also theta, this is also theta, same angle will be this side, and that will be pi minus theta. So for pi minus theta and theta, there is some relation, and that is why they are called allied angles. Next thing, 2n plus 1 pi by 2 plus minus theta. If, yeah, here also, in this case also allied angles will be formed, right? Oh my god, this circle. This case also. If we measure from here, on y-axis also this same thing will happen. So those are also called allied angles only. N pi plus n pi by 2 or pi by 2 plus minus 1 theta. 2n plus 1 pi by 2 plus minus 1 theta. N0 pi by 2. N1 3 pi by 2. N2 5 pi by 2. Right? So pi by 2 plus minus theta. The angles theta and 2n plus 1 pi by 2, these are also called allied angles. They are also allies of each other. Sir, what is the connection? What is the connection? Remember this. Simply, whenever we have pi or a multiple of pi and plus or minus theta. Pi or a multiple of pi like this, and then plus minus theta inside the ratio, that means inside sine, cos, tan. The ratio which will come out is always going to be same. So first of all, ratio which will come out will always be same. It will be sine only, it will be cos only, it will be cos only, it will be tan. Yeah, this is visible, right? It will be tan only, this will be tan only, no problem. This will be sine, pi, no problem. 3 pi cos only, this will be cos, this will be this will be tan, same only, this will be cos. Now about, sir, sine, this will be theta also I have to put, right? Why did I forget to put theta? All will come out to be same ratios. Sine, now we have to just check the sine. Sine, how will we check? We know the concept of quadrants, sir. We'll check. Pi minus theta, sir. Pi minus theta. Pi minus theta. This is pi. Pi minus theta means somewhere over here in the pi minus theta, right? Clockwise is positive, anti-clockwise is negative. So pi minus theta means second quadrant. In second quadrant, sine is positive. So this is going to be plus sine theta. Correct? Pi plus theta. Sir, third quadrant. Pi plus theta. Third quadrant. Third quadrant, what sine is positive or negative, sir? Negative. Sine means y coordinate. Y coordinate is negative in third quadrant, sir, negative. Pi minus theta, cos of pi minus theta, second quadrant, sir, second quadrant, cos is positive, negative, sir, negative. Cos is x coordinate and second quadrant, cos is negative, x coordinate is negative. Pi plus theta, fourth quadrant, this will be pi plus theta, right? Complete angle will be pi plus theta, fourth quadrant. Pi plus theta, third quadrant, what am I saying? Pi plus theta, third quadrant, cos is positive, negative, sir, cos is negative, so negative. Imagine, you will be able to do it quickly, eventually you'll remember this anyway, but you should be able to do it. Which quadrant? That's the easier way. Instead of, we have already a lot to mug up in this chapter, we have a lot to mug up for our preparations. Right, for the JEE preparations, there is a huge amount of things to mug up. Memory space is too much. Don't think, sir, we will not be able to. We will be able to. You talk to doctors. They have like gigabytes or I don't know which bytes, even more. So much of memory. So you can remember. Don't worry about it. But still, better it is to try not to mug up as much as possible. Okay. Tan 2 pi minus theta. So 2 pi minus theta. So 2 pi means complete till here. This is 2 pi. 2 pi minus theta, that means fourth quadrant, tan in fourth quadrant. Sine is negative, cos is positive. So tan will be negative. In fourth quadrant, tan is negative. Fourth quadrant, sir, tan is negative. 2 pi plus theta, sine 2 pi plus theta. 2 pi, one complete round plus theta, one more. Where will we come? 2 pi means one complete round and one more plus We are going ahead. So again we are coming in first quadrant. In first quadrant everything is positive. Without even looking we can put the sign. Correct? 3 pi plus theta. 3 pi. 3 pi means pi plus 2 pi. Right? Pi plus 2 pi. 3 pi will come here and one more chakkar will come, one more round will come, and then we'll go ahead. 3 pi plus theta. 3 pi plus theta, sir. Third quadrant. In third quadrant cos negative. 7 pi. 7 pi. Sir, 2 pi, 2 pi, 2 pi, 6 pi. 7 pi means over here. Minus theta, that means here. Second quadrant. See, no? Getting my point, right? 7 pi. Nothing. Just imagination can work very well. Very fast also, no problem. So this will be 2 pi. Then again 2 pi. That means 4 pi. One more 2 pi. 6 pi. Sir, then we'll come here. This will be our 7 pi. Then 7 pi minus theta. That means over here. That means somewhere in second quadrant. In second quadrant, sine is positive, cos is negative, tan will be negative. For now, do like this. For now, right, do like this, no problem. Eventually, you'll get habituated, you'll be able to get it easily and faster in your minds itself. Not a problem. Okay, now 180 into 5 pi, 5 pi, 5 pi, 4 pi plus pi, minus theta, second quadrant again, second quadrant cos is negative. Okay, shall we go ahead? This is how you should check the sign. Better, effective and easier method. Sign of supplementary angles are same. Sign of supplementary angles are same. Sin pi minus theta. Sin pi minus theta and theta will be same. Sin theta and sin pi minus theta will be same. Supplementary angles means sum should be 180. So theta and pi minus theta, if we'll add, sum should be pi. Pi means 180 degree. So sign of supplementary angles will be same. Sign of theta and sign of pi minus theta will be same. Cosines of supplementary angles will be negative of each other. Cosines of supplementary angles, pi minus theta and theta. Pi minus theta and theta are supplementary angles. So cosine of supplementary angles will be negative of each other. Anywhere else we have? Yeah, 3 pi plus theta minus theta, right? So negative. Supplementary angles. Sine of minus theta, I already told you. Sine of minus theta means fourth quadrant. Minus theta means fourth quadrant. In fourth quadrant, sine is negative. Sine is y coordinate, so it is negative. Cos of minus theta, sir. Cos of minus theta, fourth quadrant, sir. Fourth quadrant means cos theta will be positive. X coordinate will be positive in fourth quadrant. So cos of minus theta is equal to theta, and sine of minus theta is equal to minus sine theta. It's not equal to theta, it is equal to cos theta. That means cos can gulp down the minus sign, it won't let it come out. Sine has to give it out. Okay, simple. Piece of cake. Piece of cake. What do you think? Easy question, right? Easy question, come on. Whoever can, please answer. Sir, tan and 170 degree, 10 degree and 170 degree, sir, supplementary angles. So, sir, cos 10 plus cos 170, for example, if I am writing, 170 means, sir, cos 10 plus cos of 170 means, sir, cos of 180 minus 10, sir, pi minus 10, can I write, sir, pi minus 10, okay. Cos of pi minus 10 will be cos of supplementary angles is negative. So cos 10 and this will become minus cos 10. So cos 10 minus cos 170 will cancel each other and become 0. This will become 0. 20, 160 will become 0. 160 I can write cos 20. Check cos 20 plus cos, before this, what term will I have? Before this, which term will I have? I'll have cos 160, right? I'll have cos 160. What will happen to cos 160? Cos 20 plus cos 160. Cos 160. Cos 160. Sir, cos 160 I can write cos 20 plus cos of pi minus 20. Sir, cos of pi minus 20. Sir, cos of pi minus 20. That means second quadrant, in second quadrant cos will be negative, it will come out to be negative. You can think like this also, no problem. Do the right thing though. Okay, if you are not able to remember or mug up for the session at least, if you are not able to remember or mug up, at least do this quadrant. You have to imagine, that will also be a good practice. Cos 20 minus cos 20, pi minus 20, cos negative, cos will come out to be negative, cos 20 minus cos 20 will also become 0. Sir, cos 10 cos 170 became 0, cos 20 cos 160 became 0, cos 30 cos 150 will also become 0. Sir, cos 40 and cos 140 will also become 0. Like this, all the sums will become 0. What will be left with, sir? A big 0. Very good, sir. We like this number. 0 is the answer. Okay, let's go ahead. Allied angles in the case of pi by 2 minus theta or pi by 2 plus theta or multiple of pi by 2 plus minus theta. Ratio will change. Remember this. In case of pi plus minus or multiple of pi plus minus theta, ratio will remain same. Here in case of pi by 2, ratio will change. So this will become sir sine. This will become sir cos. This will become sir sine. This will become cot. This will become cos. This will become sine. This will become cot. This will become sec. Okay. Any problem? Anybody? No problem, sir. Cos pi by 2 minus theta, sine pi by 2 minus theta, cos 3 pi by 2 plus theta, sir, sine theta, this is theta. Let's put theta also. Why do I forget to put theta? Okay, put theta. Now checking the sign. Pi by 2 minus theta, first quadrant. Pi by 2 is 90 degree, minus theta, that means first quadrant, only first quadrant, everything is positive, sir, positive. Sine pi by 2 minus theta, everything is positive, sir, positive. We know this also, right? If you know this from 10th class, 90 minus theta is sine theta, cos 90 minus theta is sine theta, and sine 90 minus theta is cos theta. 3 pi by 2, sir, 3 pi by 2. 3 pi by 2 means this one. 3 pi by 2, that means this one, right? This one. 3 pi by 2 plus theta, fourth quadrant, sine, y coordinate, negative. 5 pi by 2 minus theta, sir, 5 pi by 2, okay, where will 5 pi by 2 be? Just now I told, right? Pi by 2 plus pi, pi by 2 plus, here we have pi by 2 plus pi, 3 pi by 2, 3 pi by 2 plus pi, 5 pi by 2, that means here, this will be pi by 2. Or you can do pi by 2 plus 2 pi, like that also you can think. Pi by 2 plus 2 pi will also be 5 pi by 2, so this will be 5 pi by 2, right? 5 pi by 2 minus theta, that means again first quadrant, everything is positive, no problem. Sine 90 plus theta, cos theta, sine 90 plus theta, pi by 2 plus theta, second quadrant cos will be, you have to look at the sign of this one. Okay, 3 pi by 2 plus theta, did I do wrong here? Cos will be positive. You have to look for the sign for this one. No, not for sign. Sign of this one. What we are changing? Sign of this one. So cos in fourth quadrant, yes, 3 pi by 2 plus theta, fourth quadrant, cos has to be positive. Cos is x coordinate. This will also be positive. Tan in fourth quadrant, tan and cot, both will be negative in 5 pi by 2 plus theta, right? Both cot, tan, everything will be positive. Sine 90 plus theta, pi by 2 plus theta, that means second quadrant. In second quadrant, sine is positive, so this is also going to be positive. 270, that means 3 pi by 2. 270, that means 3 pi by 2, and 270 minus theta, that means third quadrant. In third quadrant, sir, cos is negative, so here we have to look for the sign of this one, what we are changing. Okay, what we are changing. Tan 270 minus theta, that means 270 means 3 pi by 2, minus theta means third quadrant. That means tan in third quadrant is positive because sine and cos both are negative, so it is going to be positive. Cosec 270 plus theta, cosec 270 means 3 pi by 2, 3 pi by 2 plus theta, that means fourth quadrant. In fourth quadrant, what is sine? Sine is negative, so cosec will be also negative, so there will be a negative sign. Clear everybody? I hope everybody understood. Any problem, any difficulty? Those who have started from late, let me know. First of all, please try to join on time. Otherwise, no problem, watch the recording later, because you know what happens is that some part will be missing. But I understand everybody has a different schedule. It's not necessary that you have to work according to the live session schedule on a particular day. So you can watch the recording. For now, keep listening, don't worry. If there is a big doubt, I'll respond. You tell me in the chat. Now look, sine square 10 degrees, sine square 20 degrees, sine square 30 degree, 40 degree, 50 degree, sine square 90 degree, sine square 90 degree, okay. Sir, sine square 90 degree, okay, I know. Sine square 90, I know this is going to be 1. Okay. Sine square 10, I look at something I can see. Can you also see between sine square 10 and sine square 80? Allied angles. Allied angles. Sine square 10 plus sine square 90 minus 10, can I write? Pi by 2 minus 10. Sir, you can write pi by 2 minus 10, that means cos square 10. So sine square 10 plus sine square 80. 90 minus 10, right? Pi by 2 or 90 only I should write, so that you don't get confused. 90 minus 10, right? So this is also, this will become sine 90 minus 10 cos 10, cos square 10, sine square 10 plus cos square 10. Okay. Oh my God. Okay, this is going to be 1. I know this. So sine square 10 plus sine square 81. Sine square 20. So 1 I'll get by sine square 10 plus cos square 10. This will be 1. Sine square 20 plus cos square 20. Sir, this is also 1, sir. Sine square 30 plus cos square 30. This will also be 1. Can you tell me how many will come? How many times will you have? We'll have 4 times. Sine square 10 plus cos square 10, sine square 20 plus sine square 70. Sine square 70 again means cos square 20, right? Sine square 40 and sine square 50. Sine square 50 means cos square 40. So sine square 10 plus cos square 10, sine square 20 plus cos square 20, sine square 40 plus cos square 40. 4 times we'll get 1. After this also, right? 30 and 50. 30 and 40. Sine square 30 and cos square 30 will also come. So we'll have 4 times 1. This we know, right? This is 1. Sine square theta plus cos square theta is 1. Same theta, for same theta, sine square and cos square will be 1. So that is why we are going to get 4 into 1 and plus 1. This we cannot forget. We might make a mistake in this. This is also important. This we did not calculate. We have clubbed 10, 80, 20, 70, 30, 60 and 40, 50, right? We have clubbed those. So this is 1. 4 into 1 plus 1, 5 will be our answer. Sometimes we might need to use something like this. So when you see angles in the question in terms of pi or degrees, multiplied or added, you know, try to look for allied angles. Always try to look for allied angles. Why? Because that is where the catch will be hidden. That is where the catch will be hidden. Sir, sine pi by 7. Okay, sine pi by 7. Can I write it as cos 5 pi by 14? How will I write? Sir, if I do sine pi by 7, that means sine pi by 2 minus pi by 14. If I do sine pi by 2 minus pi by 14, what will I get? 7 pi minus pi, that means 6 pi by 14, 3 pi by... Not pi by 2 minus 5 pi by 14. So pi by 2 minus 5 pi by 14. How much it is? 14 LCM 277 pi minus 5 pi. So it is going to be 2 pi by 14, which is again pi by 7, right? So pi by 2 minus 5 pi by 14. Sine of pi by 2 minus 5 pi by 14 means sine of 90 minus theta. Sine of 90 minus theta is cos theta. So cos 5 pi by 14 is also correct. No problem. And you can see pi by 2 minus 5 pi by 14 is pi by 7 only. We wanted pi by 7 only. Sir, how will we look at it? Sir, check. 5 pi plus pi, 6 pi. No, this also you have to make 14. But ratio if we make pi by 7, I can write it as 2 pi by 14 also, no? Right? And 5 pi by 14 and 2 pi by 14. Now I can see Sir, these are complementary. Why? 5 pi by 14 plus 2 pi by 14 is 7 pi by 14, which is pi by 2. Sir, complementary angles. So we can write them as allied. That means there's be something common in them. Maybe the sign difference or something common. We can relate them. Complementary. Complementary means sum is 90, pi by 2. Here also, if we check, sir, 3 pi by 7 and pi by 14. 3 pi by 7, can I write it as 6 pi by 14? If I write 3 pi by 7, this 3 pi by 7, if I write it as 6 pi by 14. If I check 6 pi by 14 and pi by 14, 6 pi by 14 plus this pi by 14 is going to give me 7 pi by 14. That means pi by 2. Okay, so that means I can write, this is how you have to check. That means you can write cos 3 pi by 7 as cos of pi minus pi by 14. Pi by 2 minus pi by 14. Pi by 2 minus pi by 14. Okay. So this will become sin pi by 14. 90 minus theta. This will become sin pi by 14. That means cos 3 pi by 7 can also be written as sin pi by 14, because 3 pi by 7 plus pi by 14 are complementary. Their sum is equal to 90, pi by 2. Okay. Let's go ahead. Sin square pi by 8, sin square 7 pi by 8. 7 pi by 8 plus pi by 8, 8 pi 8, right? What will we get here? Can you check this one? 7 square pi by 8 and 7 sin square 7 pi by 8. 7 pi by 8 plus pi by 8, 8 pi by 8, that means pi. That means they are supplementary. So, supplementary, what can we do about them? Can I write it as cos square also in terms of cos? Can I write in terms of cos? Check, come on. Check, check, check. Or can I write in terms of pi plus pi by 8 only? Pi or pi plus pi by 8. Can we do this? Come on, try this on your own. This will come out to be 2. Supplementary angle, 7 pi by 8, pi by 8. 5 pi by 8, 3 pi by 8. Just a minute. Till then you can try. I'll just come. I'll just be able. Yes. What should we do? Supplementary angles. Can we change? Am I audible? Is my voice audible? Somebody please. Is my voice audible, guys? I just hit the wire of the mic. Yeah, I think it should be audible. Is the voice audible? Somebody please reply. Okay. Yeah, what should I do? See, think sin square pi by 8, sin square 7 pi by 8. They are supplementary, making pi 7 pi by 8 plus pi by 8. That means 8 pi by 8 pi. We cannot change anything. Then sin only will remain. Supplementary angle, sin will remain sin, cos will remain cos. No change. So how will we add? How will we deduce it? Instead, if I look over here, 3 pi by 8, sin pi by 8 and sin 3 pi by 8. Sin square pi by 8 and sin square 3 pi by 8. 3 pi by 8 plus pi by 8. 4 pi by 8 pi by 2. Oh. Right? That means this one you have to write like this. This one you have to write as sin square pi minus pi by 8. 8 pi minus pi 7 pi by pi by 2 minus pi by 8, not pi minus pi by 8, pi by 2 minus pi by 8. So it will become 3 pi by 8 only. Pi by 2 minus pi by 8 will be 3 pi by 8. Now what you can do, this will become cos square pi by 8. Right? Here also the same thing will happen. Right? Pi by 2 minus 5 pi by 8 will give you 7 pi by 8. Pi by 2 minus 5 pi by 8. Okay, now let's move ahead. Where is this? So what will come here? 2 will create over here sine square pi by 8, cos square pi by 8, and here also one more 2. So 2 plus 2. No, sorry, 1. This will be 1 and this will be 1. Sine square pi by 8 plus cos square pi by 8, 1, and this also will give us 1. Sorry, my bad. The general table you know already, right? This table you know. If one simple thing over here I can tell is, I'm sure that you'll know how to make it. You just need sine values 0, 30, 45, 60, 90. So what you can do, you can start like this: 0 by 4 square root, 1 by 4 square root, 2 by 4 square root, 3 by 4 square root, and 4 by 4 square root. If you struggle in remembering these values, although it is a must that you have to remember these values, but still, 0 by 4, 0, 1 by 4 square root is 1 by 2, 2 by 4 is 1 by 2, square root of 1 by 2 is 1 by root 2, 3 by 4 square root is root 3 by 2, and 4 by 4 1. So sine values you will get. For cos, just reverse the sine values, that means these ones, and tan, sine theta by cos theta is tan theta. So you'll get, only over here you'll get not defined or infinity, 1 by 0. Tending to infinity, okay, not exactly. These values, sir, sine 120. Now as we are reading further, we'll have more values. Sir, sine 120, sir, sine 120, can I write it as sine 90 plus 30? 90 plus 30, pi by 2 plus theta. So second quadrant, sine will be positive only. So that means 90 plus 30 can be written as sine 90 plus theta is cos theta, cos 30. Cos 30, I know, sir, root 3 by 2. Sine 150 you can write as 180 minus sine pi minus 30. Sine pi minus 30. Right? Sine pi minus 30 means sine 30 only. Second quadrant, sine 30 only. Sine 30 we know 1 by 2. Cos 120. Cos pi by 2 plus 30, right? Cos pi by 2 plus 30, that means minus cos pi by 2 plus 30, second quadrant. So sine, and sine will change, cos pi by 2 plus 30 will be sine 30. Sine 30 in second quadrant, sine 30 negative, that means minus 1 by 2. Cos 150 also you can find. Cos 150, why? 180 minus 30, pi minus 30. Cos pi minus 30 will be minus of 30, minus of cos 30, right? Sine 210, 180 plus 30, pi plus 30, sine pi plus 30, pi plus 30, that means third quadrant. In third quadrant, sine is also negative, cos is also negative, so negative value will come out, right? Negative of sine 30 will come out. Same, sine will remain sine only, pi plus minus, sine will remain sine, pi by 2 plus minus, or a multiple of pi by 2 plus minus, sine will become cos, cos will become sine. Ratio will be opposite of each other. If we are doing pi plus minus or a multiple of pi plus minus, then ratio will remain same. Sine 1050, choose a multiple of 180 near 1050, I think 900. Yeah, 180, 180 into 10. No. Right? You have to choose a multiple of 180 or 90 nearby this. What is it? Let me check. (180 into 5 will be 900, and 900, so 150 will remain. 150 again we'll have to further convert. This one, what you can do is, here only you must be thinking, rest all you can find easily. Sine of, So this is 180 into 5. That means 5 pi. Right, 900 plus 150, 5 pi plus 150, 5 pi, right? That means 5 pi plus 5 pi will come at left side, right? And plus means third quadrant, 5 pi plus 150 will remain, sine will become negative minus of sine 150 it will come. Sine of 150 itself, you'll have to write it as sine of pi minus 30. Sine of pi minus 30 positive only, sine 30 is 1 by 2. So this will come out to be minus 1 by 2. The value will come out to be minus 1 by 2. Sine 135, 90 plus 45. Right, sine 90 plus 45. So cos 45 minus, cos 45. Sine 90 plus 45, sine of sine in second quadrant, 90 plus means second quadrant. So sine of cos of 45, again 1 by root 2. Rest you can find. 405 also you can find the nearest multiple of 180 near. So it will be 360 only, right? 2 pi plus 45. 2 pi cos of 2 pi plus 45. Pi or multiple of pi plus minus theta will be give us same ratio. That means cos only 2 pi plus. That means first quadrant everything positive. So cos 45 only. So this will be 1 by root 2. Right, practice them once on your own. We have in one complete lecture we have to complete it. That is why there is a constraint with me to move faster. But I would request all of these practice on your own, whether you're watching live or recorded later. But practice, write once and do. If you have not done, don't just read or think that we'll get it, right? There might be some mistakes or some things which you can do. Again over here, 2 pi by 3. Pi minus pi by 3. Right, like this, convert them like this. Sine of 2 pi by 3, that means sine of pi minus pi by 3 can I write? 3 pi minus pi, 3 pi minus pi, 2 pi by 3. So sine of pi minus pi by 3 will remain sine pi by 3 only, and positive only, second quadrant pi minus. So second quadrant sine will remain positive, it will be sine pi by 3 only. Sine pi by 3 means sine 60, root 3 by 2. This will come out to be root 3 by 2. Similarly, pi minus pi by 4 if you will do, 3 pi by 4 you will get, right? Pi minus pi by 6 if you will do, 5 pi by 6. So convert them once. Here, 2 pi by 3. Sir, pi minus pi by 3. Cos, let me solve few more. Pi minus pi by 3. 3 pi minus pi, 2 pi by 3, correct. Cos pi minus pi by 3 is, cos is negative, pi minus means second quadrant. So cos is negative in second quadrant. So I'll get minus of cos pi by 3. Pi by 3 means 60 degree minus of cos 60 minus of 1 by 2. Okay, like this you can find other ratios as well, not a problem. 7 pi by 4. Sir, how will I write 7 pi by 4? Yeah. Try 7 pi by 4, cos of 7 pi by 4. Now how, sir, 4, if I want to write, see what method you can apply or choose your own method. Every student also comes up with a different method, whatever suits to your brain, right? Or whatever suits to you, just use that method. I can suggest for conversion. So 7 pi by 4, cos of 7 pi by 4 we have, right? So what I do usually is I can write it as 4 pi plus 3 pi. 4 pi plus 3 pi by 4. So now I'll split this. 4 pi by 4, that means cos of pi plus 3 pi by 4. Okay. So this will become pi plus means third quadrant cos will be negative. So minus of cos 3 pi by 4. Now 3 pi by 4 you already know, 3 pi by 4 you know how to write. So you can write as minus of cos of pi minus pi by 4. Pi minus pi by 4, again negative. So pi minus pi by 4, second quadrant cos will be negative. So again it will come out to be negative, and what do we have? We'll have cos pi by 4 only. This will be 1 by Okay, so this is how you can split 5 pi by 6, 6 pi minus 5 pi by 6, cos 5 pi by 6, I can write it like this, no? 6 pi minus 5, 6 pi minus pi by 6. So what will it become? Pi minus pi by 6. 5 pi can be written as 6 pi. Multiple of 6 I have to see. Here multiple of 4 I saw. Behind or ahead. Anyhow you solve, you'll get the same answer. Anyhow you solve, you'll get the same answer. Here what am I trying to do? 5 pi I want to create 6 pi minus pi. So this is pi minus pi by 6. Cos pi minus pi by 6 will be minus of cos by 6. Okay. Okay, this is how you have to think and calculate. Now more values, the general ones you know. 120 means Sine 120 means sine 90 plus 30. Sine 90 plus 30. That means sine 30 only. Second quadrant. So sine 30 is cos 30. Sorry, sine 90 plus 30 will be cos 30. What am I saying? Sine 90 plus 30 will be cos 30. Second quadrant, sine will be positive, volume will be positive. Cos 30 is root 3 by 2. 135. 90 plus 45, sine of 90 plus 45, cos 45, 1 by root 2. 150, sine of 150, that means sine of pi minus 30. Sine of pi minus 30 will be sine 30 only, sine 30 is 1 by 2. 180 is 0 only, sine on pi is 0. Left side, right? Sine on pi is 0. Similarly, cos values, you know, cos of 120, that means cos of 90 plus 30, 90 plus 30, cos will become negative. Second quadrant, 90 plus 30, cos will be negative, right? So negative of 1 by 2, cos of 90 plus 30 will be sine 30, sine 30 is 1 by 2, negative of 1 by 2 will get, right? This is how you can remember this value also. These are going to be frequently used. I am still not, till now I'm not asking you to remember anything because there is a lot of stuff to remember ahead of it. For example, these values. From these ones also, no, tan 15, from these one also, I would recommend you should definitely directly in JEE Mains, at least they can ask these values. These values they can directly ask you, right? These ones. At least these you have to remember. Remaining you'll be able to at least derive. So cos, sine, yeah, in the further session ahead, I'll also explain you, I'll tell you how these came up. It's not like randomly, these are derived only. These are derived from trigonometric formulas only. But it is better to remember because these values can be directly used in the question. And derivations of some of these are very big and long. You cannot sit in the exam and waste time on deriving these values. Yeah, if you are practicing well from your books and from whichever material you are following, if you are practicing well there, then definitely you will be able to derive. Aditya, what are you trying to say? N ka hai? I didn't get. Okay, divide by 360. Okay, these values at least try to remember so that you can direct. Achha, how to remember? Many students do ask, sir, how to mug up, sir? We are very bad at memory. How to remember these many stuff? See, you are preparing for a very high level competition. If you're even preparing for JEE Mains also, no, then also very high level competition is there. So what things you can do? One thing which I followed you during my studies, that I used to walk and remember. I used to walk and mug up. Chemistry, organic chemistry, definitely math formulae. In trigonometry only this much is there. Some more chapters are there where you'll have to remember things. But how to remember? Two methods. Once, write and remember. Walk and mug it up. Write it down to keep it stuck in your head. And paste it on the wall of your room to keep refreshing it till the exam. 3 steps. Walk and mug it up. Walking. Like this, walk and remember. Okay. Then what you can do is, second step was, write it down. Whatever you have mugged up, write it down on a paper so pictorial memory gets stuck in your head. After that, whatever you have written, stick it on the wall of your study room so that you keep revising it. It will become intact for the lifetime. Trust me. Okay. Graph. For now, we are not getting into the details of the graphs. We'll understand it in functions chapter. There we'll get the understanding of graphs better. For now, we need to know how the graph looks like. This is how sine curve, sine wave. You must have heard, right? The wave. This is like this. Okay, both sine and cos, wavy graph. Okay, wavy graph is going to be comment Aditya. Okay, wavy graph we have. Okay, so now this is how it's going to be. What we need to know is, sir, where sine gets 0, where it gets 1. So we know sine 0 is going to be 0, and then again sine gets 0 on pi. Remember this, right? Sine is 0 here, then pi also here 0, then 2 pi 0, 3 pi 0, 4 pi 0, 5 pi 0. So sine is getting 0 at pi, then 2 pi, then 3 pi, then 4 pi. Where will it be positive 1? Sir, it will be positive 1 at pi by 2 here, then again 3 pi by 2 here, then again 5 pi by 2. So it will be positive 1. Here it is positive 1, here it is positive 1, 3 pi by 2 it is negative 1. Pi by 2 it will be positive 1, pi by 2 plus 2 pi, that means 5 pi by 2. So it will be positive 1. Remember 4n plus 1, right? Pi by 2, 5 pi by 2, and keeps going on like that. 9 pi by 2 and so on, right? Where it will be negative 1, sir, here 3 pi by 2, 3 pi by 2 plus 2 pi, 7 pi by 2, negative 1, and same this side, minus pi, minus 2 pi, minus 3 pi by 2, same this type on the negative side. For sine graph, just remember it will start from here, 0, it is 0 at 0, sine 0 is 0, so it will be like this. For cos, we'll just shift it a little bit like this. Acha, yeah, before cos, let's go to cosec. Cosec means reciprocal graph. Reciprocal graph means nothing but you have to create the upside down graph of the same graph in every section. For example, here it is like this. So from this one to this one, it will just be like this. From this one to this section, it will just be like this. From this section to this section, it will just be like this. From here to here, it will be like this, and here to here, it will be like this. That's it. This will become cosec. This will become sec. This will become sec because this is the graph of cos. So cosec, actually the cosec here, and this will become here and here. It will be like, this will be the graph of cosec, right? Cosec, all upside down, same curves upside down, same curves upside down, and we know also, right? Same curves upside down. Remember, right? Cosec is not defined. That means tending to infinity on which value? 0 itself. 0 itself. Cosec 0 tending to infinity, right? Okay. Cos x first. Okay, I directly made the caps upside down caps. No problem. Okay. Now this one. Cos. First of all, listen for cos. Cos it 0 at 1. Cos theta is 0 at 1. Right? I'm sorry, what is cos 0? At 0, y is equal to cos x. So cos 0, we are just simple explanation for right now to understand how the curve looks like this. So if we'll put values, no, cos 1, then value of y, cos 2, then value of y, cos 3. So that will give us a graph like this. For now, you can understand that. Okay, cos 0 means here, y, cos 0 is 1. Cos 0 is 1. So graph will start from here. So now same sine graph, we have shifted a little bit back, and it will give us the cos graph. Just remember, cos is at x is equal to 0, that means cos 0 is 1. At x is equal to 0, that means cos 0 is 1. And cos pi by 2 is 0. Cos is 0 at pi by 2. Cos 90 is 0. Cos is 0 at pi by 2. After pi by 2, 3 pi by 2, 5 pi by 2, it will keep going on. Cos is 1 at 0, then pi, on pi it is minus 1. Remember, right? Cos 0 at cos is 0 at 0 degree. Cos 0 degree is 1. Cos pi, that means this side minus 1. 2 pi 1 minus 1 1 minus 1. It will keep going on. That's why we are getting a graph like this. Okay, tan sec will be just upside down. So same things upside down, same these things only upside down over here, and here also, right? Here also upside down. Same curves, just upside down. Same curves, just upside down. Tan x, tan 0, wherever sine will be 0, tan will be 0, right? But at pi by 2, the problem occurs at pi by 2. So at positive pi by 2, it will tend to positive infinity, and negative pi by 2, it will tend to negative infinity. 1 by 0 not defined, tending to infinity. Although it is not defined, but we say tending to infinity. So tan 0 will give us y is equal to 0. Whenever sine is 0, tan is 0, simple thing. So here tan will be 0. On positive pi by 2 side, it will be tending to positive infinity, and here tending to negative infinity. Positive infinity, same thing. Same thing. How will we reciprocal it? Same thing will reciprocal like this. So this part reciprocal will be this. Same part. It was like this. Oh, my drawing does not help me at all. How was it like this, like this? For your reference, I am drawing for now. Like this it was. So now just reverse of it, just inverse of it. Now actual trigonometry will start. The formula, a lot of formulas are there, so pay attention, stay tight. If you have, yeah sir, bolo. Which chapter going on next time? Which chapter next time? Next time, let's see. Maybe binomial or quadratic also we have pending, right? Quadratic also we didn't do. Quadratic equations, very important, because that we'll be needing for other chapters also. Today also we could have done maximum and minimum values of these trigonometric functions, but because of quadratic only, I'm keeping that for some other part. Very important thing, very important, mug them up as it is. Mug them up as it is. Derivations very lengthy, and also even if you'll derive, anyway you'll have to remember them. Anyway you'll have to remember them. Sin a plus b, sin a cos b plus cos a sin b. Sin a minus b, sin a cos b minus cos a sin b. Simple to remember, sin a plus b, sin a minus b. Repeat after me. Even if you are watching it later, repeat after me. Sin a plus b, sin a cos b plus cos a sin b. Sin a minus b, sin a cos b plus minus cos a sin b. Right, minus will come. Very easy to remember. Cos a plus b, opposite. Here the sign will be opposite. If it is cos a plus b, it will be cos a cos b minus sin a sin b. If we have cos a minus b, it will be cos a cos b plus sin a sin b. In sin we have sin cos. In sin a plus b we have sin cos and same sign. In cos a plus b and cos a minus b we have cos sin, and in between opposite signs are there. Okay, mark them up right now itself. Cos a cos b minus sin a sin b. These formulas, guys, write them, first mug them up, write them down on your own. After that, paste them in the wall of your study room, on the wall of your study room. You must have a lot to paste on your study room's wall if you are preparing for any exam. Even for 11th, 12th, you are preparing, no? And you want to score better. It should look, your room will tell somebody that how much are you dedicated. A student's room tells the story of his dedication. That's a fact, trust me. Believe it or not. That's a fact. That's a fact. Yeah, tell me, Aditya, which question are you talking about? Okay, that's the fact. Okay, next. Tan a plus b, tan a plus tan b upon 1 minus tan a tan b. Okay, tan a plus tan b upon 1 minus tan a tan b. You can derive this by sin a plus b cos a minus b, cos a plus sin a, you can derive it as like this also, sin a plus b upon cos a plus b, but then again that will be a very lengthy process, lot of division and all. Why to do that? Every time you cannot derive, right? If there are even 4 or 5 steps involved. So we'll remember tan a plus b, tan a plus tan b upon 1 minus tan a tan b. Tan a minus b will be tan a minus tan b, numerator will be same sign, denominator sign will change. So tan a plus b is tan a plus tan b upon 1 minus tan a tan b. Tan a minus b is tan a minus tan b upon 1 plus tan a tan b. Cot a plus b is cot a cot b minus 1, product minus 1 divided by cot a minus cot b. Cot a plus b, so cot a plus cot b. Cot a minus b is cot a cot b plus 1 divided by cot a minus cot b. Here, no, not cot a minus cot b, here it will be cot b minus cot a. Okay, let's go ahead. Evaluate sin 15 degree, cos 75 degree, tan 15 degree. Just now we saw these values, right? Now we can evaluate using these formulas, compound angle formulas, right? Compound angle formulas. By compound angle formulas I mean this only, okay? Nothing different. These things, a plus b, a minus b for tan, cos and sin. Okay, sin 15 I'll derive. I'll tell you how. You have the idea now. Now you know how to derive actually. If you are listening carefully, you know how to divide. Sin 45 minus 15. Sin 45 minus 15. Sin 45 minus 15, that is sin a minus b. What is the formula, sir? Sin of a minus b. Sir, sin a cos b. Sin, if sin a minus b means it will be sin cos, and sin will be same. The sin minus cos a sin b. No problem. So it will be sin 45. Sin 45 cos 15. But sir, oh, sin not 15. How am I writing 15? I have to write 30, right? 45 minus 30. 15 already I have to find. How can I write 15? So cos 30. Sin a cos b minus cos a, that means cos 45. Sin b, that means sin 30. Okay ji. Now all the values I know. These values I know, right? 1 by root 2 into cos 30 root 3 by 2 minus 1 by root 2 into sin 30 1 by 2. Correct? Okay. So what do I get? Root 3 minus 1 by 2 root 2. If you want to rationalize, you can rationalize also. You can keep the value like this. If we rationalize, what do we get? Actually, better to rationalize, because you should remember the values as 2 minus root 3 and 2 plus root 3. So how will we get that? How will we get that? You know rationalization already. Root 3 minus 1 by 2 root 2. What will you do? You'll multiply by 2 root 2 and 2 root 2. Or rationalize the upper part. Root 3 you can multiply with root 3 plus 1 also. Root 3 plus 1 upon root 3 plus 1 over here. So it will, numerator will become root 3 plus 1 into root 3 minus 1. That means 3 minus 1, 2. Here what we'll have? 2 root 6 plus 2. So we'll get 1 by root 6 plus 1 also. Many forms. You can get different forms. Sin 15, cos 75, tan 15. Derive all of them on your own. Right? Remember this slide. All, it's better that we can remember these values simply. It's better that we can remember these values. Root 3 minus 1 upon 2 root 2. Sometimes you might have a rationalized form, right? All these values. Tan 15, how will you derive? Tan 45 minus 30. Tan 45 minus tan 30 upon 1 minus tan 45 into tan 30. Right? All these values you can derive. 18 also, with more formulas as we go ahead with the chapter, we'll be able to understand how all these values can be derived easily, but recommended is to remember. Recommended is to remember. What happened, Aditya? What is the problem? 360 minus 30. Yeah, that was correct. What is to comment on that? What is to comment on that? Okay, ji. Compound angle formulae. Remember the formulae. Very important. Cos 75. Cos 75 can we calculate? How? First we can calculate cos 15 or directly 45 plus 30. Right, 45 plus 30, cos 45 plus 30 we can do. Cos 45 plus 30 you can do. Cos 45 plus 30, cos A plus B. Cos A cos B minus sin A sin B. Right, cos A cos B minus sin A sin B. So you'll get all the values. You can derive all the values. Many of them with the compound angle formula. Recommended it is to remember them. Alright, what is tan 15 degree? First let's derive tan 15 degree. Okay, let's derive. Here in this question, see, this question is very easy actually. If you see, question is came in mains of 2023 and question is not that difficult, doesn't look that difficult. Why? Because see, I know 195 sir, 180 pi plus 15. Okay sir, 105 90 plus 15, 75 90 minus 15. So I can get all of them. If I get 10 15, I'll get many of them. I'll get most of these values. So my purpose should be, sir, finding tan 15. Although my purpose should be, I should remember tan 15. 2 minus root 3 or 2 plus root 3. Right? Tan 15 and tan 75 both recommended at least to remember. Okay. Let's, tan 15 we are talking about. Tan 15. Tan 15, that means tan of 45 minus 30. Please pay attention everybody, don't lose attention. Attention plays the major role while studying. Okay, if we don't pay attention, it is going to be really a problem in exam. Right, focus time period should be increased. Don't just hop on to, sir, sometime we'll study, sir, half an hour, sir, 45 minutes, then we'll take a break. No, exam itself is of 3 hours. So your attention time span should be more than 4-5 hours. Trust me. Okay, sir, 45 minus 30 is fine. 45 minus 30 is 15. Tan 45 minus 30. So tan 45, tan A minus B, tan A minus tan B upon 1 plus tan A tan B. Tan A, tan 45 will be 1 only. Tan 45 will be 1 only. Tan A minus tan B. Tan A minus tan B. Tan 45 minus tan 30 upon 1 minus 1 plus tan A tan B. That means 1 plus tan 45 into tan 30. Tan 45 is 1 only, so 1 plus tan 30. What is tan 30? Sin 30. Sin 30 by cos 30. 1 by 2 upon root 3 by 2. So 1 by root 3 can we say? This is going to be root 3 minus 1 upon root 3 plus 1. Am I correct? Tan 30. Tan 30 is 1 minus 1 by root 3 and tan, so tan 30 is 1 by root 3 and here we'll get 1 by 1 plus 1 by root 3. So root 3 minus 1 upon root 3 plus 1. Right? Root 3 will get cancelled. Now is this the correct value? We can rationalize this more, sir. We can rationalize, then rationalize. Root 3 minus 1 will multiply in the numerator and denominator. Okay, so numerator will become root 3 minus 1 whole square. Denominator will become root 3 square minus 1 square. So this will be 3 plus 1 minus 2 root 3. Denominator will be 3 minus 1, that is 2. 3 plus 1, 4 minus 2 root 3. If I 4 minus 2 root 3, 2 if I take common, it will be 2 minus root 3 upon 2 will get cancelled. So that means a tan 15. So tan 15 is equal to 2 minus root 3. If I ask you what will be tan 75? Tan 75. Can I say tan 75 is tan 90 minus 15? Can we say that? Tan 75 is tan 90 minus 15. Tan 90 minus 15. That means cot 15. Cot 15 means root 3 plus 1 upon root 3 minus 1. So this will come out to be 2 plus root 3. Correct? Cot 15 means when we'll calculate, we'll get root 3 plus 1 upon root 3 minus 1 and we'll rationalize, we'll get 2 plus root 3. So then what else do we need? 105. 90 plus 15. Right? Now we have 15. So no problem. Tan 105 also we can find. tan 105 also we can find tan 90 plus 15. Tan 90 plus 15, second quadrant, tan will be negative. Negative, it will be equal to minus of tan 15. We have tan 15. So it will be root 3 minus 2. It will be root 3 minus 2. So tan 105. So tan 10, no, what else do we need? Tan 195 we need. So tan 195 also we can find. Tan 195 will write as tan of pi plus 180 plus 15. So pi plus 15. Tan of pi plus 15 is positive. Third quadrant, tan is positive. So it will be tan 15 only. Same value it will be. 2 plus 2 minus root 3. This will be 2 minus root 3. So we have all the values. Now nothing, no problem. Right? Okay. We can get all the values. We'll just put the values and we'll get the answer. Very, very uncalculative. So we'll get the answer is equal to 2a and we have to find a plus 1 by a. Okay. Can you calculate yourself? We'll do more questions, right? 2 minus root 3, 1 by tan 75. 1 by tan 75, can I say cot 75 only? Cot 75. 1 by tan 75, cot 1 by tan 75, cot 75. Cot 75 means tan 15. Again. Right, cot 90 minus 15, so tan 15 only. So same value. Most of the values over here will come out to be same. Right. Calculate this once on your own. Do comment the answers. Okay, if there is any problem in the question, you're getting stuck or anything, comment, put in the comment box. I'll send you the complete written solution. For now, let's try to do more and more questions in the given time. Tan pi by 4 plus theta will always, this result, just now we actually understood this result, but you should, it's better that we remember them. Remembering also very easy. Tan pi by 4 plus theta, pi by 4, pi by 4 means 45 degree. 45 degree, tan 45 is 1. Right, what is the formula? Tan pi by 4, for example, first one I'll show you, tan pi by 4 plus theta. Tan a plus b, we have to use the formula of tan a plus b. Tan a plus b is tan a plus tan b upon 1 minus tan a tan b. That means tan pi by 4 plus tan theta upon 1 minus tan pi by 4 tan theta. Right, so tan pi by 4 is 1 plus tan theta upon 1 minus 1 into tan theta, that means 1 minus tan theta. So this is, whenever we have tan pi by 4 plus theta, it will be 1 minus tan theta upon 1, tan pi by 4 plus theta, that means 1 plus tan theta upon 1 minus tan theta. If we have tan pi by 4 minus theta, then we'll have 1 minus tan theta upon 1 plus tan theta. Right, opposite. If we have minus here, then say minus above, denominator positive. Here plus, so minus numerator, plus numerator and denominator negative. Instantly also it will come into your mind, but sometimes, you know, in questions this is quite needed. For example, over here itself, can we prove this? How will we prove this? I'll prove this part. Look, cos theta plus sin theta upon cos theta minus sin theta is written as tan 45 plus theta. No, allied angles formulas we cannot apply here, but what we can do is cos theta plus sin theta upon cos theta minus sin theta. Sir, this side I want tan. So cos theta plus sin theta, only idea from any past experience, what idea do we get? Sir, what do you do? Sir, you do divide it by cos theta, right? So as soon as I divided it by cos theta, both numerator and denominator I'll have to do. This will become cos theta by cos theta, that means 1, plus sin theta by cos theta, that means tan theta. Cos theta by cos theta plus sin theta by cos theta. Cos theta by cos theta 1, sin theta by cos theta, tan theta. Denominator cos, this will get cancelled anyway. How can we cancel? We have only divided, right? So this will become 1 plus tan theta, this part, and this will become cos theta by cos theta 1 minus sin theta by cos theta tan theta. So 1 minus tan theta. And this is only tan of 45. That means pi by 4 plus theta. Numerator plus, right? So plus theta. But still, remember them as results. Remember them as results. Sometimes if you see this, practice. It's not everything I'm asking you to remember. But when you'll practice a bunch of questions, no, more you remember, better you will be, faster you will be, more pace you will have. Pace is what matters, right? Pace is what matters. So this is going to be, I'll ask you to remember these as results only. Remember these as direct results only, not a problem. Next thing. If we now benefit of using the results, suppose a plus b is equal to 45 is given to us and they are asking us to on the same identity. See, every question in trigonometry, will give you a result, and more questions you will do, better you will be at, because you'll be able to remember. You'll remember, okay, I solved that question, there I was getting this, so this is how I can relate. Now this question also is going to help you further. Now look at this, 2 into 1 plus tan A into 1 plus tan B. Now 1 plus tan B. B I can write as 45 minus A. Simple thing. I'll do B, I can write as 45 minus A. So I'll do 2 into 1 plus tan A multiplied with 1 plus tan 45 minus A. This thing I'll do. And as soon as I do this, now how to use the last question that we solved. 1 plus tan A, sir, I can see that over here 1 plus tan 45 minus A, that means 1 minus tan A upon 1 plus tan A. Correct? Right? So now, simple. Now 1 plus tan A I have over here. This will be 1 plus tan A only. This will remain 1 plus tan A. Numerator, if I take LCM, what will I have? 1 plus tan A plus 1 minus tan A divided by 1 plus tan A. So this gets cancelled, not a problem. 1 plus 1, 2, tan A minus tan A, 0, 2 into this 2 will give me a 4. What did we learn? 1 plus tan A into 1 plus tan B will be equal to 2 if A plus B is equal to 45 degree. Directly it can be used somewhere. 1 plus tan A, what we can deduce from here? 1 plus tan A into 1 plus tan B is going to always give me a 2 if A plus B is equal to 45 degrees. Simple to understand, simple to remember, not a problem, not a problem. Okay, ji? Sir, notes for sequence. Oh, I didn't upload the notes for sequence and series. Must have forgotten. I have it saved. I'll ask the team to do it. My bad. Okay, don't mind. That's my bad. I should have. How did I forget? Dekh, power of speaking English. No power of speaking English. Speaking English is for being able to support the entire Indian students. Right? Anybody, there should not be language barrier in education. Simple thing. What I understand is, it's okay. There should not be any language barrier. Be it Hindi, English, Kannada, Telugu, Tamil, Sindhi, Marwadi, Punjabi, anything. Whatever you understand, we try to serve as better as we can. Okay, that's the job of a teacher. Nothing else. Okay, I'll just drink water. Try to do this. Okay. This came in 1975, way back. I think that time, in fact, subjective papers used to be there. I don't know. that is much before then, even when I was born. 56 by 33. Very good, Saurav. You remember the answer. Good. Good. Cos alpha. What is asked? Tan 2 alpha is asked. Tan 2 alpha is asked. Okay, and alpha beta both lie between 0 and pi by 4. Okay, 0 and pi by 4. 0 and pi by 4. 0 and pi by 4. That means, okay, 0 and pi by 4. That means maximum they can be between pi by 2 and 0. If both of them become pi by 4. So maximum value will get at pi by 2. Now minimum value, both of them become 0, then we'll have 0. But minimum value will be for alpha minus beta. Alpha minus beta can go to minus pi by 4 also. So we'll have to take care there. That is why this question is of JEE. That means something can be catchy or tricky over here. Not a problem. We'll think about it. Cos of alpha plus beta is 4 by 5. Okay. So can you tell me sine of alpha plus beta? Can you tell me sine of alpha plus beta? 3 by 5. No problem. Alpha plus beta will be in 0 and pi by 2. So we don't need to worry about it. Okay. Can you tell me tan of alpha plus beta? Tan of alpha plus beta. So tan of alpha plus beta is going to be P by B. So 4 by 3. 4 by 3 is fine. Sir, 4 by 3 is fine. Okay. Then alpha beta. Now sine of alpha minus beta. So we should find cos of alpha minus beta. What will be cos of alpha minus beta? Come on, tell me in the chat. Cos of alpha minus beta. Come on. Waiting for your responses only. Can you tell me cos of alpha minus beta? Anybody? Good. Am I getting replies later or something? Because something is wrong. I think there is a problem. There is a problem. Let me check. Tan of alpha minus beta. Tan of alpha minus beta. Both alpha and beta lie between 0 and pi by 4. So we don't need to worry about it. Tan of alpha minus beta will be. Groy, sir, what happened? Yeah, tell me. Tan of alpha minus beta. 5 by 12. Right? 5, 12 and 13. Sin alpha minus beta is P by H. So 5 by 13. Right? P is 5. H is 13. B can be 12. So 5 by 12. Can I say? Okay. Now, sin of alpha minus beta is positive. Sin is positive in first and second quadrant. So tan of, so and where is 0? Where can our angle lie? Our angle can lie between minus pi by 4 to pi by 2. Minimum it can go to minus pi by 4. Right? And maximum it can go to pi by 2. Even if you want to check, although here we don't need to check. Right? Maximum it can go here. And sine is a positive. Sine is a positive. That means it can be first or second quadrant. What is intersection? That means it is definitely first quadrant. We are only talking about first quadrant. Now we don't need to think about maximum minimum value. Right? Although we have to take care that where the angle minimum can go. Because alpha minus beta is there. No. Alpha minus beta can be minus pi by 4 also. Minus pi by 4 also. In that case. But then we see, sir, sine of alpha minus beta is positive. That means it is not in fourth quadrant, it is in first or second. And sine is positive in first or second, right? So tan of alpha minus beta, we have to think about. And our region is this. Our region is this. That means this is where we are looking for. First quadrant only. Okay. Anything? Now, tan of alpha minus beta 5 by 12. Acha, tan of 2 alpha. Let's go to the point only. No? Why are we wasting time? Tan of 2 alpha, can I write it as alpha plus beta plus alpha minus beta? Can I write it like this? Any problem in this? No problem, sir. Tan alpha, this became tan A plus tan B or tan X plus tan Y. Anything, right? What is that? That is equal to tan of alpha plus beta plus tan of alpha minus beta upon 1 minus tan of alpha plus beta into tan of alpha minus beta. We have all the values. We have all the values. Tan of alpha plus beta we have, tan of alpha minus beta we have. Yeah, we can solve this. So 3 by 4 plus 5 by 12 upon 1 minus 3 by 4 into 5 by 12. 3 by 4 plus 5 by 12 upon 1 minus 3 by 4 into 5 by 12. We'll solve this and get the answer. 56 by 33 only. I think that should be the correct. Somebody said, right? 56 by 33. I remember that. Was it? Saurav Jha. Very good. Very good, boy. Very good. Good. Yeah, common question. General question, common question only. Not a problem. Right. Common question, because the students who are solving will remember the answers. That's very good. Sometimes that is even required. That will be helpful. Sine of A minus B upon cos A cos B, sine of B minus C upon sine C sine A. We have to use this. We have to prove this. We are supposed to prove this. How to prove? Sir, we know if the sum is, everything is becoming 0, that means everything is either getting cancelled or either product in the product and it is getting cancelled, or sums and differences. So we have to create like that. We have to start with what we know. We know sine A minus B formula. Sine A minus B formula, that means sine A cos B minus cos A sine B. This formula we know. Cos A cos B divided plus sine B cos C minus cos B sine C. This formula we know. We have cos B cos C plus sine C cos A minus cos A cos C sine A. C sine A. Don't mind my handwriting. Upon cos C cos A. So we'll get an idea. Sine A cos B upon cos A cos B. That means sine A by cos A. Yes, right? Sine A. Now split the term. A by, for example, A minus B by 2. We write it as A by 2 minus B by 2, right? Right. So here also sine A cos B upon cos A sine B. Cos A cos B will get cancelled. What will remain? Sine A by cos A. Here cos A sine B upon cos A cos B. That means sine B by cos B. Correct? Plus sine B cos C upon cos B cos C. That means sine B by cos B minus cos B sine C upon cos B cos C. That means sine C by cos C. Plus sine C cos A upon cos C sine A. That means sine C by cos C. Cos A sine C upon cos C cos A. Cos A, this will be cos C sine A. So sine A minus sine A by cos A. Did everything get cancelled? Yes, this and this gone, this one and this one gone, this one and this one gone, all came out to be 0. Remember, right? All came out to be 0. Tan x plus tan y is equal to sin x plus y. Very important result. Remember this as a riddle. Again, I'll write. This you will get to use in questions. Remember this. We'll prove this, but remember it as a result. Again, I would recommend that you can remember this as a result. Tan x plus tan y is equal to sin x plus y. Tan x minus tan y is equal to sin x minus y. Can we prove this? Yeah, we can do that. Tan x means sin x by cos x plus tan y means sin y by cos y upon tan x means sin x. Break it in. We want sin right on the right side, so we have to break tan and sin cos terms. So sin x by cos x over here minus cos y by sin y. Now you must have understood what to do next. No? Sin x cos y, sin x cos y. Take the LCM. Cos x cos y will be the LCM. What we'll have here? Sin x into cos y plus cos x into sin x into cos y plus sin y into cos x. That means cos x into sin y only I can write directly. Divided by cos x cos y cos x cos y divided by, whole divided by, is my handwriting too bad? Please tell me if it is like that. Here sin x into sin y, sin x sin y minus cos x cos y, minus cos x cos y divided by cos x cos y. Oh my god, very good. This gets cancelled. Whenever I say oh my god, a sound from background comes into my head. I don't know. Can you guess that sound? I don't know if you watch memes or not. Okay, cos x into cos y. Here this got cancelled. Numerator I have sin x cos y plus cos x sin y. That means sin of x plus y. Numerator becomes sin of x plus y. Denominator sin x sin y minus cos x cos y. Sin x sin y minus cos x cos y. Sin of x minus y. No. Did we do something wrong? Sin x by cos x. Oh, here we have written wrong. Nobody is telling me only. Here we have written wrong. Sin y by cos y it will be. So it will be sin x cos y. Here also I have written wrong. This is why. Sin x cos y it will be, and cos x sin y it will be. Yeah, it will be cos x sin y. So it will be sin of x minus y. Correct? That's why. But remember this as a direct result. We might get to use this somewhere or the other. Okay. Tan x plus tan y upon tan x minus tan y can be written as sin x plus y upon sin x minus y. Again, tan x plus tan y upon tan x minus tan y can be written as sin x plus y upon sin x minus y. Come on, let's move ahead. Tan A is equal to x tan B. Prove that sin A minus B upon sin A plus B is equal to x minus 1 upon x plus 1. See, here only we got to use this. Let's see. How many of you can tell me where to start from? There to there. You know that now something like tan x plus tan y upon tan x minus tan y you have to create, or tan A plus tan B upon tan A minus tan B if you are able to create. In that case, you can get sin A plus B upon sin A minus B. Right? Or sin A minus B upon sin A plus B, whatever it is. But how to create that tan A upon tan B? Okay, tan A upon tan B, tan A upon tan B. How will I create tan A plus tan B upon tan A minus tan B? You must have heard about one thing. Suppose if A by B is equal to, remember this, okay? Although you have, most of you do, but still, just once. So that A by B is equal to C by D. If A by B is equal to C by D, if we add 1 both the sides, we get A plus B by B is equal to C plus D by D. Correct? If we add 1 both the sides, right? This will be true. If this is true, this will be true. If we add both one both the sides. If this is true, then A minus B by B will be equal to C minus D by D also. Why? Because I subtracted 1 both the sides. Minus 1 both the sides. So we'll get A minus B by B is equal to C minus D by D. If I divide these two, what do I get? I get A plus B upon A minus B is equal to C plus D upon C minus D. And this is what we call componendo and dividendo. You remember this, right? Componendo and dividendo. This is what is called, just revision so that you remember it for componendo, dividendo we call it. Now you must have understood what to do simply. So tan A by tan B, we have it as x. X by 1, no problem. Okay, tan A by tan B is x by 1. So we can write tan A plus tan B upon tan A minus tan B is equal to x plus 1 upon x minus 1. Not a problem, right? Both sides. A by B was equal to C by D. So A plus B upon A minus B is equal to C plus D upon C minus D. That's what we have done. This we know. This is sine of A plus B upon sine of A minus B, which is equal to x plus 1 upon x minus 1. So what do we need? We need reciprocal of it. Reciprocal both the sides. We got what we want. Compound angle formulas here also. These results, same, we have used this only. Sine A plus B into sine A minus B will be written as sine square A minus sine square B. Sine A plus B into sine A minus B. You don't need derivation, although you know. I'll just visualize it to you. I can just visualize it to you so that it's easy for you to remember. Sine A plus B will be sine A cos B plus cos A sin B. Sine A minus B will be sine A cos B minus cos A sin B. So can we say sine square A cos square B minus cos square A sin square B, right? We need now change. Now here put, instead of cos square A, you can put 1 minus cos square B, 1 minus sin square A, right? And you'll get the same result. Here also put cos square B. If I put sin square A, cos square B as 1 minus sin square B, right? And here if I put cos square A as 1 minus sin square A into sin square B. Now here see sin square A into sin square B, minus of sin square A into sin square B, and here we'll have minus minus plus sin square A into sin square B. Sin square A plus sin square A into sin square B and minus sin square A sin square B will get cancelled. What will remain? Sin square A minus sin square B, right? This is what we'll get. Similarly, you can derive this also. Cos A plus B into cos A minus B is cos square A minus sin square B, and it is also equal to cos square B minus sin square A. How? Because if you write cos square A as 1 minus sin square A and sin square B as 1 minus cos square B, then you'll get this one. Both are same. It does not matter you take B first or A first. Remember, cos A plus B into cos A minus B is cos square A minus sin square B or cos square B minus sin square A. And sin A plus B into sin A minus B is sin square A minus sin square B. Very important result, very important results. Okay. One more important and good result. Okay. Tan 8A, tan 5A, tan 3A is equal to tan 8A minus tan 5A minus tan 3A. How? Can you think of proving it? Can you think of proving it? Come on. Hanji, can you think of proving it? Yes, guys. Tell me. Simple thing. One thing we can notice is, sir, 5 plus 3 is 8. There is nothing to notice in that. Sir, 5A plus 3A is equal to 8A. We can start with what we know. This is what we know. Because this type of identity we didn't see only till now, no? We just know one thing, that sir, 5A plus 3A is equal to 8A. So if 5A plus 3A is equal to 8A, I can take tan both the sides. If two angles are equal, their tans will be equal. Simple thing to understand, right? If two angles, two entities are equal, their tans will also be equal. So I can take tan both the sides. What am I going to do, sir? Tan of 5A plus 3A will be equal to tan of 8A. Okay, sir, no problem. Okay, no problem. So this side, what am I going to do? Because I want tan 8A, right? And I know sum and product I have to create. So tan 5A plus 3A will be tan 5A plus tan 3A upon 1 minus tan 5A tan 3A. This is the formula. Tan A plus tan B upon 1 minus tan A tan B is equal to tan of 8A is equal to tan of 8A. Now what? We got what we want. No? We didn't? We didn't? Arey, we got. This will become tan 5A plus tan 3A is equal to tan of 8A multiplied with 1 minus, this will go that side, no? Here only I'll shift it. 1 minus tan 5A tan 3A. One step will be saved, no? Tan 8A minus tan 8A tan 5A tan 3A. That's what we got. Now we got what we want, right? Tan 8A, tan 5A, tan 3A. Bring this side. Take these two that side. So tan 8A minus tan 5A, tan 3A. And remember this also, that whenever A plus B, when A plus B, oh sorry, not A plus B, I should write like this. Whenever one angle is equal or can be written as the sum of two others, that means A is equal to B plus C. If we can write A is equal to B plus C, then in this case tan A tan B tan C will be equal to tan A, greatest angle, minus tan B, smaller, minus tan C, smallest. This is something which we can remember from this result. Second question also, same way we can prove, isn't it? Right? Yes, anything? Nothing in the chat? Okay, no problem. Important result. Why did I write? It was already written. My God. Tan A, yeah, you remember, right? Tan A, tan B, tan C is equal to tan A minus tan B minus tan C if A is equal to B plus C. If A is equal to B plus C. If A is equal to B plus C. Here also same thing. No, not same thing. Huh? Why? I can write, no, tan 315 is equal to tan of 200 plus 115. No. No. What is tan 315? So tan 315, 90 into 3, 270, 270 plus 45. 270 plus 45, right? So can I write 270 plus 45? 270 means 3 pi by 2. No? 270 means 3 pi by 2. 270 means 3 pi by 2. So 270 plus 45. So tan 270, 3 pi by 2 plus 45. That means fourth quadrant. So tan is negative. Tan is negative. So it will be minus tan 45. It will be minus 1. So tan 315 I can directly write it as minus 1. Here itself I can write minus 1, and here I'll break tan 200 plus tan 115 upon 1 minus tan 200 into tan 115. Shift them and you'll get the result, same result. Okay. This question came this year itself. A bit calculative question, but not difficult, we cannot say. But yes, we can call it calculative, a little bit calculative. Okay, give it a try. Just a minute. I'll drink water. Come back. Yes. Anything in the chat? Nothing in the chat. My God, chat is dead. Okay, ji. And now tan A, tan B. I know tan A's value is given, tan B's value is given. Thinking approach. Let's discuss about how to think towards the question. Tan A is given, tan B is given. Tan C, okay, A plus B they are asking. And tan A and tan B are given. Simple, my mind should directly think that means they are asking me to apply tan A plus B. If tan A is given, tan B is given, A plus B they are asking, what do I know? I know tan A plus B. What else? Right? So I can apply tan A plus B. That's the only thing I can start with. Root of, I'll have to remember, I'll have to change the page. So 1 by root of x into x square plus x plus 1, right? Let me write and then check. Tan A is given to me as 1 by root of x square plus x plus 1, right? This is what we have. Root of x is also there. So root of x I'm multiplying here only, right? and here we have root of x upon root of x square plus x plus 1. Tan b is root of x upon root of x square plus x plus 1. Okay, no problem. Now what do we do? Tan a plus b. Now they are asking us a plus b. So we'll find tan of a plus b. We'll apply tan a plus b formula. So this is going to give me tan a plus tan b. That means very calculative it is going to be. So I'll be erasing some steps. Keep following, okay? Keep following. Root x multiplied with root of x square plus x plus 1. Okay, plus tan b. That means root x upon root of x square plus x plus 1. Okay. Tan a plus tan b upon 1 minus tan a tan b. Tan a plus b will be tan a plus tan b upon 1 minus product of these two. 1 by root x into root of x square plus x plus 1. We could substitute something for root of x square plus x plus 1, but still, it's okay. Don't be afraid of calculation if you want to love mathematics. Right? Enjoy calculation. Calculation again increases our attention time span. Okay. Now here, what am I going to get? Root x divided by root of x square plus x plus 1. Right? Now, what else? Nothing else. I can take the LCM. What else can I do? LCM means product of these two. Product of these two means root x will come as it is, and this square root into square root will become x square plus x plus 1. Right? Numerator, what we will get? This multiplied with root of x square plus x plus 1 will give us this. So numerator will have root of x square plus x plus 1. Okay, ji. Plus root x, this is what we have. We want this. What should be multiplied with? Root x into root of x square plus x plus 1. If this thing will multiply with root x into root of x square plus x plus 1, then we'll get this. So here what we'll have? Root x into root x first x. Am I doing it right? Root x into root x will means x, and here we'll have root of x square plus x plus 1. Okay. Denominator. Denominator, what we'll have? Denominator, this thing will go here, so it will be root of x into this will get multiplied. That means x square plus x plus 1 and minus 1 divided by the product of these two. That means root x into x square plus x plus 1. Now I can take the breath of peace because I know things are getting cancelled. This is okay, not a problem. My term has deduced. Deduced to what? From numerator there. Can I take root of x square plus x plus 1 as common and then write 1 plus x here? Right? Divided by, from here, this is 1 minus 1 became 0. X square plus x, x I'll take common, root x is already there, x root x I'll do. Right? What will I have? X plus 1. Very good. Super awesome. Right? One more thing got cancelled. Now what do I have? I have root of x square plus x divided by x root x. Okay ji. Okay ji. Prince, hi sir ji, how are you? Kaise ho? Long time no see. Long time no see. Now we can see, right? I still cannot see you. Okay. Okay. So what do I have? No, one more thing. You lost, made me lose my attention. This was x square plus x plus 1 here, and if I send this x inside, what will I have? Root of x square plus x plus 1 divided by root of x cube, isn't it? X will go inside square root, so it will become x cube. Now what I can do is, I can take square root of x square by x cube plus x by x cube plus 1 by x cube. Okay, so this is going to give me x square by x cube will give us 1 by x, or can I directly write x to the power minus 1, right? X to the power minus 1, x to the power plus x to the power minus 2 plus x to the power of minus 3 square root. Okay, this is what we wanted, right? This is something what we wanted. Yeah, square root, power 1 by 2, so square root. Tan C, this is equal to tan C. This is equal to tan C. That means, can I say that my tan of A plus B is equal to tan C? That means A plus B is equal to C. Not a problem. Common question. Very easy it was. Just a bit calculative. Nothing else. Okay. This we know, right? If A plus B is equal to 45, 1 plus tan A into 1 plus tan B is 2. Directly we can answer. Sir, 2. We know already. We know already. Can we apply it here? Yeah, directly we can apply. Sir, 1 plus tan 1 into 1 plus tan 4, 44. Right? 1 plus tan 1 into 1 plus tan 44. Sir, 1 plus tan of 1 into 1 plus tan of 44. Will it give us 1? Will it give us 2? Will it give us 2? Tell me, will it give us 2? Yeah, it will give us, because 44 plus 1 is 45. A plus B is 45. This will become 2. Similarly, tan of 1 plus 2 and tan of 1 plus 43 will also become 2. So how many terms will it come to? Come on, tell me in the chat. How many terms? Two terms, right? 44 half is 22. 22 terms. Can you understand this? Analyze this. Yeah? 22 terms. 22 terms. Here we'll have 22 terms. So 22 times 2 to the power 22. 22 terms will be there, so it will become 2 to the power 22, and here also we are getting a 2. 1 plus tan 45. 1 plus 1 is 2. So into 2. That means 2 to the power 23. So n is equal to 23. We can say. Some more formula. Some more formulae. Multiple angle formulae. Sin 2 theta, cos 2 theta, tan 2 theta. Sin 2 theta means sine of theta plus theta. You have to anyway remember this, but still I'm just telling you how, if you somehow forget, how to revise. Sine of theta plus theta, that means sin theta cos theta plus cos theta sin theta. So 2 sin theta cos theta. What we'll get? 2 sin theta cos theta. Cos 2 theta means cos of theta plus theta. Cos A cos B minus cos A minus sin A sin B. So cos square theta minus sin square theta. Cos square theta minus sin square theta. Tan 2 theta, tan of theta plus theta. Tan theta plus tan theta upon 1 minus tan theta into tan theta. So 2 tan theta upon 1 minus tan square theta. Simple. Even if you, although this should be on your tips, you should remember them, but in case you forget. Sin 2 theta, 2 sin theta cos theta, cos 2 theta, cos square theta minus sin square theta, tan 2 theta, 2 tan theta upon 1 minus tan square theta. Similarly, this is double angle formula. Suppose if I am writing cos of 60 degree, so it is going to be equal to cos square 30 degree. That means half. Half of 2 theta is theta minus sin square 30 degree. If I am writing sine of let's say 64 degree, so it will be equal to 2 sine 32 into cos 32, right? So it is like this also. Sine theta, sine 2 theta is 2 sine theta cos theta. So sine theta can be 2 sine theta by 2 cos theta by 2, right? Very useful and important formula. Suppose you have to make an angle double or half, write it in terms of its, suppose you have 22.5 and you want to make it double of 22.5 is useful because it is 45. We know the values for 45. So in those cases, definitely you'll get to use these kind of formulas, right? 2 sine A cos cube A minus sine 2 sine cube A cos A. Any idea? Try it for a while. Give it a minute. Have a look. Try on your own. Even if you're watching live or recording, trying is better than directly looking at the solution because you'll forget the solution after a while. Right? Direct. You must be getting a hint. Simple hint. Simple algebraic hint. Sine A cos A. Sir, we can take common. What we will take common? Sir, 2 sine A cos A I can take common. What will remain inside? From here sine A cos A. So cos square A will remain inside. Minus from here sine square A will remain inside. 2 sine A cos A will give me sine 2 times A. Right? 2 sine A cos A, sine 2A. 2 sine 2 theta, 2 sine theta cos theta. Okay, multiplied with cos square A minus sine square A, cos 2A. So sine 2A, cos 2A, directly I don't have any formula, and look in the options, we have 4A. 4A will be created when we have double angle formula. So for double angle formula we need 2. So if we are multiplying with 2, we'll divide with 2. 2 sine 2A cos 2A. 2 sine theta cos 2 sine theta cos theta, that means sine 2 theta, that means sine 4A divided by 2. Okay. Cos 4A minus sine 4A. This also you can solve, right? Write it as cos square theta minus sine square theta multiplied with cos square theta. By looking at the question itself, right? You can think of this sine square theta. A square B minus A minus B into A plus B is A square minus B square. So we can write like this. This we know is cos 2 theta. This we know is 1. This part is 1. Sine square theta plus cos square theta is 1. Directly we are getting answer. Right? It's not necessary this only will come. But yeah, by looking at the question, you need to get the idea. Cot theta minus tan theta, 2 cot 2 theta. This also by using sine by cos itself, you can easily prove. Cos theta by sine theta by cos theta. Cos square theta minus sine square theta in the numerator, denominator sine theta cos theta. Cos square theta minus sine square theta is cos 2 theta. Sine theta cos theta is nothing but 2 sine theta cos theta is something, right? So we'll multiply here by 2 and in the numerator also, and then we'll have to divide also. So numerator it will get multiplied, right? Now it will become sine 2 theta, 2 cos 2 theta upon sine 2 theta is cot 2 theta, and this is how we can easily prove. Do them on your own also. It's not that this much is enough. Achha, this question we already solved, right? How did it come again? This one, sine of something into sine of something else plus cos of something into cos of something else. This is, this is of the form cos A cos B plus sine A sine B. Can we say that? What is this? Cos A minus B, right? So cos of A minus B. So cos of what we'll have? Cos A cos B minus sine A sine B, right? Cos of n plus 1 into x minus n plus 2 into x. That's it. Solved. Direct, formula based. Many times formula based questions can also be asked, at least in mains, definitely. Direct. Otherwise, in other chapters, definitely 100% sure you can be that you'll get to use these direct identities many times, right? So be well practiced about all of these. Why is the chat not working for me? Can you hear me, everybody, clearly? Wait, just a minute. Nx minus nx, x minus 2x minus x, cos of minus x, cos of x. Even now it's not working, right? Wait, let me see. Let me just fix my internet. There is some problem, I think, so that I can look at the chart. Chart is important, right? What if I'm audible or not? Stay connected, don't go away. Yeah, it started working for me. Yeah. Right, nx minus nx is 0 and x minus 2x will be minus x, cos of minus x is cos x. Find sine 2a if sine a minus b is given to you and cos a plus b is given to you. How? Sine a minus b is given to you, cos a plus b is given to you. Sine 2a, you just have to write like this. Sine 2a, you can write like this. Sine of a plus b plus sine of a minus b. Simple. And the question is done for you. Right? If you get such a case, then just 2a, just write like this and apply sine a plus b formula, sine x plus y formula. Right? And you'll get the answer directly. Not a problem. Right? So this will become sine a plus b into cos a minus b plus cos a plus b into sine a minus b. Just take all angles as acute only and you'll get the answer. You have to get the other values. You have sine a minus b, you need sine a plus b, you'll get from here and you can solve this. The catch over here is that sometimes you might have to not directly use sine 2a formula because sine 2a is written. Sometimes you have to, if a plus b and a minus b is given and 2a is asked, then use sine a plus b formula or sine x plus y formula. Here again, good question asked in JEE Advanced, but no, do you see it can be very difficult or right? Nothing? Any ideas? Anything? What idea can we get? 0 to minus pi by 4 beta is and 0 to pi by 4 my alpha is. Okay, not a problem. That won't make much of an issue for me. They are acute only. We can directly say that. Right, cos is positive. So beta is between 0 to minus pi by 4. Alpha minus beta will also come positive, right? And alpha plus beta positive. So we don't have to worry about the quadrant. Here what should we do? Here what should we do? Directly if we start taking the LCM, no, it will create an issue. So what can I do is, I can club this one and this one. What can I do is, I can club this one, I can club with this one. Why? Because sine A, sine B I am getting and cos A, cos B I am getting. Right? So this one if I'll club, what will I get? Sine, I'll write sine alpha by cos beta plus cos alpha by sine beta together. Plus these two I'll club together. So cos beta by sine alpha and plus sine beta by cos alpha I can club together. Such a case. And there is a square we'll do later, not a problem. First pay attention here. Sine alpha, sine beta. What we'll get? Sine alpha, sine beta plus cos alpha, cos beta. by cos beta sin beta bone beta. Okay. Plus cos alpha cos beta plus sin alpha sin beta. Okay ji, divided by sin alpha cos alpha. Okay. Now most of the work is done. Sin alpha, here we have cos alpha minus beta, here we have cos alpha minus beta, this is also cos alpha minus beta. We have it already. Shall I directly write cos alpha minus beta, and this is also cos alpha minus beta? One more step I'll write cos of alpha minus beta divided by cos beta sin beta plus cos of alpha minus beta divided by sin alpha cos alpha. Okay. Sin of alpha minus beta, no, cos I have, cos, yeah, that was cos. Cos of alpha minus beta here divided by, what do we have, cos beta sin beta, cos beta sin beta sin alpha cos alpha, cos beta sin beta plus cos of alpha minus beta divided by cos alpha sin alpha. Okay. Right. So numerator I can see directly, cos of alpha minus beta is given to me as 2 by 3. So 2 by 3 I am taking common, 2 by 3 I am taking common. It multiplied with 1 upon, now this will become, can I write it as 2 sin beta cos beta? So if I am multiplying here, I'll have to multiply in the numerator also. It will become 2 by sin 2 beta plus here again I'll have 2 by sin 2 alpha. Okay, but the problem is here also I'll have to calculate a little bit more. Why do I have to calculate a little bit more? Tanisha, yes sir, we can use formula, we can expand sin. Yes, very good Tanisha, very good. Great, great. But now what to do? Now we don't have sin 2 beta. No, we created sin 2 beta, but we don't have. What do we have? Alpha plus beta and alpha minus beta. That means we have to again split this thing further. 2 by 3 and 2 again common. So let's make it 4 by 3. 4 by 3. And here we'll have 1 by sine of alpha plus beta plus minus alpha minus beta, then only 2 beta will be created, no? And here again 1 by sine of alpha plus beta plus alpha minus beta. That's how we are going to get to our answer. Now not a problem. Now we can put the values. We have all the values. We have sine alpha, cos alpha, sine alpha minus beta, cos alpha minus beta, sine alpha plus beta and cos alpha plus beta. All of the values we have, so we are going to get the answer. The catch is that after here, don't get stuck. After here, you know that 2 beta I have got, but I don't have the value of beta. What I have is, neither I have the value of beta nor I have the value of alpha. What I have is values of cos alpha minus beta and cos alpha plus beta. So that's how. Let's see the calculation. And greatest integer is asked. Remember, okay? Don't forget that also. Greatest integer is asked. So basically, this will get you to this, right? This part, sine alpha, this is sine alpha, sine x minus y. So sine x cos y minus cos x sine y. So 1 by 3 into 2 by 3 minus 2 root 2 by 3 into root 5 by 3. And here we'll have 1 by 3 into 2 by 3 plus 2 root 2 into root 5 by 3 into 3, right? So finally we are getting something like this, minus 4 by 3. This part we are getting as minus 4 by 3. Square will get as 16 by 9. Square of minus 4 by 3 will get as 16 by 9. Greatest integer, 16 by 9 is also 1 point something something. 1 point something. So greatest integer will come out to be 1. 1 will be your answer. Many times we the only thing to understand in this question was that we should not get stuck at this part here. After that, what to do? After that, what we are supposed to do? Hi Krish, what's up? How are you? Are you the same Krish I'm thinking about? Amazing Krish, the super Krish. Okay. Cos 2 theta, 3 important results. One result we know, cos square theta minus sin square theta. Right? Second result, in this only, if instead of cos square theta, if I put here only, if I put instead of cos square theta, if I put 1 minus sin square theta minus sin square theta, what will I get? I'll get 1 minus 2 sin square theta. And if I put here in this one only, if I put sin square theta as 1 minus cos square theta, what do I get? Cos square theta minus 1 plus cos square theta, that means 2 cos square theta. Very important. See, in the other compound angles, in the other multiple angle formulas or compound angle formulas, this one, cos 2 theta, sin 2 theta, especially cos 2 theta, is used a lot. 2 cos square theta minus 1. Very good, Tanisha, very good. You're following completely, very nice. So this is going to be, remember, this is something which we have to mug up, keep it stuck in our head, intact. And how to mug up, I've told you how to remember these formulas. The best way which every student can use is what I've told you. If you want me to repeat it, 3 steps. First step, walk and mug up, write and keep it stuck in your head. Then how to revise and keep it intact by pasting those writings on the walls of your room. Your room should look like a study room, a room of an aspirant, okay? Not a room of just student, okay? 2 cos square theta minus 1, 3 important results. Moving ahead. Yeah. 2 more, very important. Directly we'll get to use this. 1 plus cos 2 theta is 2 cos square theta. Simple to understand. 1 plus cos 2 theta. 1 plus cos 2 theta means 1 plus cos square theta minus sin square theta. Oh, if we'll use this, no, we are not getting anything. 1 plus cos 2 theta. Cos 2 theta, if I write it as 1 minus 2 sin square theta, what will I get? 1 plus 1, 2 minus 2 sin square theta. No, not getting anything. Let's write it as 2 cos square theta minus 1, because I want in terms of 2 cos square theta, no? So 1 minus 1 will become 0 and we'll directly get 1 plus cos 2 theta is equal to 2 cos square theta. Remember it. Remembering, and this way you will derive. So deriving also helps you to remember. Deriving helps you to give confidence on your memory. Derivations are, that's why they are important. Is there any formula in terms of n? Yes, Tanisha will come ahead. We'll go ahead, and there are more formulas. There is a pool of formulas. Don't worry about formulas. I'll, dig you up with the formulas today. There are too many formulas. 1 plus cos 2 theta is equal to 2 cos square theta, and 1 minus cos 2 theta. 1 minus cos 2 theta. 1 minus cos 2 theta. Cos 2 theta, if I write it as 1 minus 2 sin square theta, if I write the same thing, then 1 minus 1, 0, minus minus plus. So I'm getting 1 minus cos 2 theta as 2 sin square theta. Remember these directly as result. Big I'm writing remember. Mug them up. Why am I continuously asking you to mug up these formulas? Because without formulas, the question will become too lengthy for you to solve and the time is limited. Direct formula based questions will be there in mains, even in advanced sometimes. But although trigonometry is rare in advanced, mains it is too much. But in other chapters, direct application, how much time will you take to think and derive? So remember, this chapter, a lot of good memory you'll need. There is a line. Why did the line come? I don't know. Okay. All right. No problem. These ones, everybody can understand. 1 minus, again, solve, derive, very easy to derive all of them, but remember the results. Remember the result as many as you can. 1 plus cos 2 theta, 1 minus cos 2 theta, 2 sin square theta, 2 sin square theta upon sin 2 theta, 2 sin square theta upon sin 2 theta, that means 2 sin theta cos theta. This one I'm talking about, right? 1 minus cos 2 theta, directly 2 sin square theta. Sin 2 theta is 2 sin theta cos theta. Sin theta, 1 sin theta got cancelled, 2 got cancelled. What do we have? Tan theta. Sin theta by cos theta, tan theta. 1 plus cos 4 theta upon sin 4 theta. 1 plus cos 4 theta. We know 1 plus cos 2 theta is equal to 2 cos square theta. Sir, this we know. That means 1 plus cos 4 theta will be equal to 2 cos square 2 theta divided by sin 4 theta. That means 2 sin 2 theta cos 2 theta. Okay, this is how. So cos 2 theta will cancel this up, and whatever we left with 2 will also cancel. What are we left with? Cot 2 theta. We are left with cot 2 theta. This one again, same way. Easily you can use them. Sin theta can be written as 2 sin theta by 2 cos theta by 2 divided by 1 plus cos theta. 1 plus cos 2 theta is 2 cos square theta. So 1 plus cos theta will be 2 cos square theta by 2. Do them on your own, very necessarily. Do them on your own. It is important to do on your own. Even if you're watching, listening, keep a pen and paper, solve on your own. You'll remember more effectively. 2 sin theta by 2 cos theta by 2 tan theta by 2. This one is quite visible. Cos theta plus sin theta whole square. Cos square theta plus sin square theta plus 2 sin theta cos theta. Cos square theta plus sin square theta will become 1. 2 sin theta cos theta will become sin 2 theta. So cos theta plus sin theta whole square can be written as 1 plus sin 2 theta. It is easy to derive, but application will matter. Many times you'll have to directly see, oh, if I put 1 plus sin 2 theta as cos theta plus sin theta whole square, the question will become a piece of cake. And there is where you become smarter ahead of the competition. Okay, now cos theta minus sin theta whole square, cos square theta plus sin square theta minus 2 sin theta cos theta. So 1 minus sin 2 theta. Okay, here, try it. Take a minute. Right? Cos 2 theta upon 1 plus sin 2 theta. What should we do? Sir, 1 plus sin 2 theta is there and cos 2 theta is there. Tan pi by 4 theta, tan pi by 4 minus theta, this thing you directly remember, right? 1 minus tan theta upon 1 plus tan theta. This you know. Can you get this? Cos 2 theta is cos square theta minus sin square theta. Remember the formula. Divided by 1 plus sin 2 theta. Just now we saw that 1 plus sin 2 theta is cos theta plus sin theta whole square. And why am I getting this idea of putting it as cos theta plus sin theta whole square? Because I know cos 2 theta is cos square theta minus sin square theta. So what's the best thing to do is write 1 plus sin 2 theta as cos theta plus sin theta whole square. If I do this, my entire question is solved, because numerator I am getting cos theta minus sin theta into cos theta plus sin theta divided by cos theta plus sin theta whole square. This cancels this. What do I have? Cos theta minus sin theta. Sir, but this is just cos theta minus sin theta upon cos theta plus sin theta. How do we get from here to here? Come on, 10th class, 9th class also can do this, right? If you divide numerator and denominator with cos theta, this will become 1 minus tan theta upon 1 plus tan theta. Divide by cos theta and you'll get over here. Clear, everybody? Divide by cos theta. Tanisha is Doing awesome. Wow. Sec 8 theta minus 1 upon sec 4 theta minus 1. We start with what we know. What do we know? Sec theta, we don't know any formula. So first we'll create it into cos theta. Okay, so 1 by cos 8 theta minus 1 upon 1 by cos 4 theta minus 1. Is it equal to 1 minus cos 8 theta upon cos 8 theta divided by 1 minus cos 4 theta divided by cos 4 theta. What do I get? 1 minus cos 8 theta I get upon 1 minus cos 4 theta I get. And here what do I get? Here I get cos of 4 theta divided by cos of 8 theta. Now 1 minus cos 2 theta. 1 minus cos 2 theta. Sin 2 sin square theta. Right? I'll write once again. Because you see, you have to create tan. So you need to bring sine. That should be the feeling. Always pay attention on where you want to go. Math, trigonometry proving is definitely like puzzle solving. You know where to get. You just have to find the way. Right? You know where to get. You just have to find the way. So I know where to get tan. I want tan. So tan will come by sine upon cos. Where do I get sine from? I know one formula. 1 minus cos 2 theta is going to be 2 sine square theta. So here I'm just going to say 1 minus cos 8 theta will become 2 sine square 4 theta. Okay. Right. And here what will I have? Here I'll have 1 minus cos 4 theta. So 2 sine square 2 theta. And here I have cos 4 theta already. Here I have cos 8 theta. Now I can see simply, I want tan 8 theta. I lost tan 8 theta. I lost 8 theta. So I have to again create 8 theta. Simple, I can see sin theta, cos theta I can see. So 2 sin thetas are there. Sin square theta is there. So what will I do? One sin theta I'll club with cos, 1 sin 4 theta I'll club with cos 4 theta. 2 sin 4 theta into cos 4 theta will give me sin 8 theta. Right? And I'll have to multiply with sin 4 theta. 1 sin 4 theta is still remaining, right? Correct? Divided by 2 sine square 2 theta I have and cos 8 theta I have. So sin 8 theta, cos 8 theta, directly I got tan 8 theta I have already gotten. Tan 8 theta I got. And what am I left with? I am left with sin 4 theta divided by 2 sine square 2 theta. Denominator I want tan 2 theta. So 4 theta I don't need. Sin 2 theta I'll apply. What will I have? I'll have tan 8 theta multiplied with 2 sin 2 theta cos 2 theta divided by 2 sine square 2 theta. Dish. Cos 8 theta upon sin theta. So I'm writing here tan 8 theta into cos 2 theta upon sin 2 theta, cot 2 theta. Cot 2 theta reciprocal again, tan 2 theta. Clear? Remember where to go. You'll always have a direction, sir. But is there any form? What? Did you write something, Tanisha? Okay, leave it. Again here, alpha and beta are between 0 and pi by 2, so nothing to worry about. Simply 1 plus cos 2 alpha. See here we have root 2 sin alpha upon 1 plus cos 2 alpha. 1 plus cos 2 alpha are 2 cos square alpha. 1 plus cos 2 alpha is 2 cos square alpha. So square root of 2 cos square alpha is equal to 1 by 7. Okay. Here, from here what am I getting? 1 minus cos 2 beta. That means square root of 2 sin square beta. Can we say that? Divided by 2 2 cancelled. What will come out? Sine beta will come out to be as 1 by root 10. Very nice. That's what I wanted. Here, root 2, this thing, can I write it as root 2 of cos square alpha I had, right? So can I write it root 2 cos alpha? Square root of 2 cos square alpha. So 2 will come out as root 2 and cos square alpha is, this will get cancelled. Tan alpha I am getting as 1 by 7. From here also I can get tan beta. Can I get tan beta? Tan beta, P by H is there. 10 minus 1, 9, 3. 3 I should get. So 1 by 3 I'll get. 1 by 3 I'll get. Now what do I want? Tan alpha plus beta, directly formula. Tan alpha plus beta. So tan alpha plus tan beta. I'm writing again so that even while watching the session you can mug these up. You can remember. I want to make this session as fruitful for you as possible. Tan alpha plus tan beta upon 1 minus tan alpha tan beta. Great, amazing. All what I need I have. Right? Solution maybe I have. Let's check. Yeah, we have 1 by 7 plus 3 by 4. Right? And 1 minus. Yeah. Answer will be 1. Again here, same thing. Right? 0, theta is between 0 to pi by 16. First quadrant. Okay, no problem. Why do we have to pay attention at that? Because when we are taking something out of square root, here also I'll mention, here also it has to be mentioned that angle will be positive. Why? Because we are getting, when we are doing this, no, 1 plus cos 2 alpha, and we are writing it as square root of 2 cos square alpha, and we are getting square root 2 cos square alpha also we are getting out. So it is, we have to make sure that it is a positive entity. That's why we are directly writing cos alpha, right? Otherwise we'll have to write mod cos alpha, mod of cos alpha. Whatever comes out should be positive. Whatever comes out of the square root should be positive. Here we are directly writing because it's given. Theta is between, angles are between 0 and pi by 2. First quadrant, everything is positive. Here, here see, 2 plus square root, 1 plus cos, 1 plus, this can be written as 2 common, 1 plus cos 8 theta. This will become 2 common, 1 plus cos 8 theta. 1 plus cos 2 theta is, sir, 2 cos square theta. So it will become 2 into 2 cos square 4 theta, isn't it? So it will become 4 cos square theta. When we'll take it out of the square root, we'll have 2 cos theta. Directly cos theta we are taking out first quadrant. That's why. 2 cos theta. Then again we'll have 2 plus 2 cos theta. So what will come out? 2 cos. Again we'll have 2 plus 2 cos 4 theta. Right? What will come out? It will come out as 2 plus 2 cos 2 theta. Again 1 plus cos 2 theta will apply, 2 into cos square theta. So finally we'll get 2 cos theta as our answer. Right? Directly these type or this same thing can be required in the exam. Now these you know already. Now from here itself, if I want to write, suppose I have 2 sine square theta, I know it is equal to 1 minus cos 2 theta. Now suppose I have theta and I want to take it into double. I have suppose 22.5. I want to find sine 22.5, right? And what do I have to do for that? I'll just take this sine square theta is equal to 1 minus cos 2 theta divided by 2. So my sine theta will come out to be plus or minus square root of 1 minus cos 2 theta divided by 2. Sine will decide by seeing the quadrant. But if I want to find sine of 22.5, 22.5 is not a familiar number to me. Double of 22.5, which is 45, is familiar to me. So 1 minus cos 45 by 2 square root, plus or minus. Clear? So 2 more formulas here itself you can remember. that cos theta, from here only we are writing cos theta is 1 plus cos 2 theta by 2 square root plus minus 1 plus cos 2 theta by 2 square root of plus minus square root of 1 plus cos 2 theta by 2. Okay, and sin theta can be written as plus or minus 1 minus cos 2 theta by 2 square root. You know how we are getting it, but we can directly get to use it while calculating such values. Told you, right? Cos 22.5 I want to create. I know that my 2 cos square theta is equal to 1 plus cos 2 theta. So cos theta is going to give me plus or minus square root of 1 plus cos 2 theta. See, more you remember, faster you will be. You won't have to write this, right? By 2. So this is going to be plus or minus square root of 1 plus cos 45. Cos 2 into 25 will be cos 22.5 will be 45 by 2. So it is going to be plus or minus square root of 1 plus 1 by root 2 divided by 2. This is going to give me plus or minus square root of root 2 plus 1 divided by 2 root. That's how we were getting the values. All these formulas which we are learning, we can use them to get any value. Not any value, but yeah, the standard values. Not any value. Maybe take my words back. But yeah, the standard values which I showed you in the beginning, which I asked you to remember, those you can get. But see, again, it's better to remember, it's better to, do like this. Now 1 minus cos 2 theta upon sin 2 theta is equal to tan theta. Remember this also as a result. 1 minus cos 2 theta upon sin 2 theta is equal to tan theta. You can derive it. You can derive it. We can derive it, right? How? 1 minus cos 2 theta, we know what is it? 1 minus cos 2 theta is 2 sin square theta. Sin 2 theta is 2 sin theta cos theta. 2 cancel, sin 1 cancel, so it is tan theta. Derivation I am just suggesting you in case you forget, or in case you get such a situation somewhere that 1 minus cos 2 theta upon sin 2 theta is written and you are getting to, you need tan theta in some situation, or you need this value in some situation to derive. You can derive it. Now again, tan theta in terms of cos and sin. So 1 minus cos 2 theta, double angles of cos and sin 2 theta, double angle of cos and sin. Directly you should remember this. So it will become 1 minus 1 by root 2 upon 1 by root 2. Sin 45 is 1 by root 2, cos 45 is 1 by root 2. Okay. Let's go ahead. Okay, 1 plus cos pi by 8 into 1 plus cos 7 pi by 8. What can we do? 1984, long back, but still a good question. How do we do it? Any ideas? Tell me in the chat. Sir, root 2 minus, yeah, Tanisha, correct, you got correct. Very good. Root 2 minus 1. See, this one and this one in this, if I notice, pi by 8 and 7 pi by 8 are giving me 8 pi by 8, that means pi. That means something is catchy here. What is catchy here? Sir, 1 plus cos pi by 8, let it be like this only. And 1 plus cos 7 pi by 8. I want to write it as pi minus pi by 8. No problem. What will it become? It will become 1 plus cos pi by 8 into, why did I do it? Because I wanted to create a plus b into a minus b. Exactly. So this will become 1 minus cos pi minus pi by 8. Cos pi minus pi by 8. Second quadrant cos is negative, so negative will come out. Cos of pi minus pi by 8 will be cos pi by 8. And now I just have 1 minus cos square pi by 8, which I want, then I can write it as sin square pi by 8. Okay, same way, do this one. This will become sin square 3 pi by 8. Let's solve this. Check once. What is catchy? Something catchy over here. Sine square A minus sine square B. If you want to apply that, or directly the formulas which we learned just now. See, pi by 16 is not favorable to me, but pi by 8 is. Pi by 8 is double of pi by 16. Correct? Use that. Give it a minute. Come on, give it a minute. Hi, AK Ayush. Wow, similar names. Great. VVHI. Hello, bro. What's up? The world has become too swaggy nowadays, right? We guys, the Gen Z has left behind. As Gen Z is left behind. No, not Gen Z. Gen Z is millennials, the ones who were born in 92s, 93s, or those years. They are not being able to catch up with the Gen Z. That's what I should say. Sine square pi by 16. Nothing. I don't know. What should I do? Cos square. I know one thing. That, sir, 2 cos square theta is equal to 1 plus cos 2 theta. I know pi by 16 is not favorable to me, but this thing is pi by 8 is, pi by 16 double is. Okay, so let's solve. M is equal to 1 plus cos 2 theta divided by 2. So 1 plus cos pi by 8 divided by 2. Pi by 8, because pi by 8 is here also, right? Now sine square pi by 8. Pi by 8 I need. Pi by 8 I need in the answers. Cos pi by 8 I need in the answer. You can see that, right? In the 4 options, cos pi by 8 I have. So I have created cos pi by 8 somehow. 2 cos square theta can be written as 1 plus cos 2 theta by 2. Cos square theta can be written as 1 plus cos 2 theta by 2. So I have cos square pi by 8. So 1 plus cos pi by 8 divided by 2 minus sine square pi by 8. Sine square pi by 8 also I have to do something. So sine square pi by 8, I also know the formula. 2 sine square theta is equal to 1 minus cos 2 theta. So 1 minus cos 2 into pi by 8. That means 1 minus cos pi by 4 divided by 2. Done. 1 by 2 minus 1 by 2 will become 0. What will we have? Right? What will we have? What will we have? 1 by 2 plus 1 by 2 into cos pi by 8. That's what we needed. It's over there. Minus 1 by 2 plus cos pi by 4. That means 1 by root 2 upon 2. That means 1 by 2 root 2. Shall I directly write? 1 by 2 root 2. And we can see there is one option. 1 by 2 root 2 plus 1 by 2 cos pi by 8. Great. Same thing we have to do with L. Both cannot be L. Let's do with L also. 1 plus cos 1 minus cos pi by 8 divided by 2 minus sine square, right? So again 1 minus cos pi by 4 divided by 2. Are we getting 1 by 2 minus 1 by 2 is getting cancelled? Here we are getting plus, this is 1 by 2 root 2 minus cos pi by 8 by 2. 1 by 2 root 2 minus cos pi by 8 by 2 we don't have. So only M is correct, right? Only M is correct. Great. Let's go ahead. This we remember, right? Just now. 1 minus cos 2 theta upon sin 2 theta is equal to tan 2 theta. Now, I think Tanisha only was asking sine 2 theta in terms of tan theta, like this. Sine 2 theta in terms of tan theta. Sine 2 theta is 2 tan theta upon 1 plus tan square theta. Okay. You can derive this also again, not a problem. You'll be able to derive this. Convert this side, you can convert in terms of sine and cos. Okay. Right. Note them down. Remember them, mark them up. Whatever you wish. Okay. You can come from either sides. Left to right also is possible. Left to right also is possible. Right to left also is possible. But this is true. Sine 2 theta is 2 tan theta upon 1 plus tan square theta. Cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta. Directly you may get to use them. Sine double angle in terms of tan half angle. Okay. Sine double angle in terms of tan half angle. Tanisha, this is what you were looking for, right? Tech guy, hello, how are you? Tanisha was looking for this. I'll show you from left to right. Sine 2 theta means 2 sine theta cos theta, correct? And what do we want to create? We want to create tan. So what can we do? We'll multiply with cos square theta here, cos theta, and cos theta here. Cos square theta we'll have to do. Will it give us the answer? Tell me. Will it give us the answer? No, this won't. If I multiply with cos theta and divide with cos theta, what will happen? What will happen? 2, I have already 2 sin theta by cos theta. So that will give me 2 tan theta. Can I directly write 2 sin theta by cos theta into cos square theta I have. Into cos square theta I have. Array 10th class identity we remember, right? 2 tan theta into 1 by sec square theta. And sec square theta is 1 plus tan square theta. That is why we are writing this. So from right to left, right to left also you can go. It will also be easy. Try that once. Try everything. Try the entire session once on your own. And I can assure you that you'll get a good grip at this chapter. And if this chapter, you'll get a good grip at entire math of 11 and 12. Otherwise, this is like a backbone. You'll keep fracturing in every chapter. You'll keep struggling in every chapter. You'll keep coming back to these formulas if you don't remember them. So other chapters also they'll be needed. Here, tan alpha minus beta is given to us, right? Try this. Tan alpha minus beta is given to us. So can I write it as tan alpha minus tan beta? We'll start with what we know. We have to move from here to here, right? Tan in terms of sine and cos. So tan alpha minus tan beta upon tan alpha 1 minus tan 1 plus tan alpha tan beta, that we know. Now a relation between tan alpha and tan beta is given to me. So tan alpha I can write it as 3 tan beta by 2. So it will become 3 tan beta by 2 minus tan beta upon 1 plus 3 tan beta by 2 into tan beta. Here there should be a beta. Here there should be a beta. Okay, now we got right. So this will become 3 tan beta by 2 minus 2 minus tan beta will become tan beta by 2 divided by 1 plus, this will become 2 plus 3 tan square beta. 2 plus 3 tan square beta by 2. This will get cancelled. right? So what are we getting? Tan beta upon 2 plus 3 tan square beta. Now after this we are not able to move. We can move, but it's better to take the right side to this, right? It's better to take the right side to this, because I can see here I can create 2 sin beta cos beta. Look, here I can create not 2 sin beta cos beta, sin 2 beta in terms of tan beta I want, right? Sin 2 beta in terms of tan beta. So fastest approach is that if we take directly this into tan, sin 2 beta is 2 tan beta upon 1 plus tan square beta, and cos 2 beta is 1 minus tan square beta upon 1 plus tan square beta. If I'll take the LCM, I'll create something like this. I can see that. So directly use the formula of sin 2 beta in terms of tan beta. 2 tan beta upon 1 plus tan square beta, and 5 minus 1 minus tan square beta upon 1 plus tan square beta, which will give me 5 plus tan square beta minus 1 plus tan square beta. 2 tan beta upon 4 plus 6 tan square beta, which will again become tan beta upon 2 plus tan 3, 2 plus 3 tan square beta. Both are getting equal. Both are getting equal. All right. Formula. Again, it is better if you remember the following results only. Directly results. Not every time we can keep on deriving. It will be very difficult, time taking. So take a screenshot if you want. Otherwise also I'll upload this. I'm sorry for the last class, maybe I couldn't upload, or I uploaded but you guys didn't get. But I'll send these to you anyway. But again, take a screenshot now itself. I'll move, or take a screenshot with me like this so that you'll remember. Okay. Cos 224 minus cos 134 upon cos 226 upon minus cos 316. Any ideas, any hints? Anybody? No sir, we are just watching it like a movie. We are just watching it like a movie. We don't want to solve, we just want to listen how it is solved. No comments at all. Cos 224, right? So 224 is 180 plus 44. 180 plus 44, right? Cot 224 can be written as 180 plus 44. My allied angles directly I can see, right? Nothing else to apply. Cot A minus cot B formulas and all I didn't give you. Even if you remember direct also, sometimes if you can directly see that it can be easily solved, prefer that. No problem. Cot of 134, how can I write? Cot of 134. 134 means 180 minus 46. Here we are using 180, no? So here also we should do it 180. 180 minus 46 we can write. Divided by cot 226. Again, cot 226 means 180 plus 46 plus cot 316. That means cot 360 minus 44. Not 360 minus 44. I'm sorry. It should be 270 plus 46, right? Okay. So cot 180 plus theta. What is cot 180 plus theta? Third quadrant. Cot and tan are positive. So this can be written as cot 44 minus cot 180 minus theta will become minus cot theta. So plus cot 46 divided by 180 plus theta. Again it will be cot 46 plus 270 plus 46. Fourth quadrant minus, right? Fourth quadrant. 270 is 3 pi by 2. So fourth plus theta will be fourth quadrant. So here we are going to have a minus cot of, no, 270 is pi by 2's multiple. Cot 270 is pi by 2's multiple, 90 into 3. So it will be 3 pi by 2 plus 46. It will become tan. What is happening? Okay, no problem. Let's write at least tan 46. Now what? So cot, now one term I'm getting in tan. Can I convert all of them in tan? Cot 44 is tan 46. Can I write it as tan 46 minus tan 44? 90 minus theta. Cot 90 minus 44 will be tan 44. And here let it cot 46 be tan 44 again minus tan 46 be tan 46, let it remain because we are converting everything in tan. Oh, we had a minus here. So we'll have a plus here. Anything you remember from this? What do we remember from this? We must remember this, right? Sine of x plus y upon sine of x minus y was equal to tan x plus tan y upon tan x minus tan y. I told you, right? You might directly get to use the formulas. So it's better to remember. So it will be sine of 46 plus 44 divided by sine of 44 minus 46. What do we get? Here it will become sine of 46 plus 44, 90. 1 will become, and here it will be sine of minus 2, right? Minus 2, so minus will come out. So this will be 1 by minus of sine 2, right? And it will become minus cosec 2 degree. This will be correct. Getting the idea? Is there any one student? Why are you bothered, Akai, who is learning? If you are watching, pay attention here, try to learn. How does it matter who's watching, who's not watching? Like, it matters who's watching, who's not watching, but why among each other, right? More important is what can we learn, can we get something from the session or not? Whenever we have joined, even if we are watching live or recording, try to stick to the entire session. Maximum 2 shifts, 2 breaks you can take, but 4 to 5 hours of continuous studies with 15 minutes of breaks should be practiced by you, all of you. This is advised. Here, directly by looking at the question itself, can you give me an idea? What do we have to do? Something like compo divo? Huh? No. Because m plus n upon m minus n is there. Right? So tan theta, can I use this? Tan of theta plus 120 divided by tan of theta minus 120 minus 30. Device is getting double. Tan of theta minus 30, right, is equal to m by n. Does this help? Yes, sir. This helps. Tan A minus B, just apply tan A minus B. Or if you don't, but if you'll apply tan A minus B, this side, how will you create m plus n and m minus n? Won't be able to, right? So we'll apply componendo dividend to A by B is equal to C by D. Then A plus B by A minus B is equal to C plus D upon C minus B. That I know. That means tan theta plus 120 plus tan theta minus 30 divided by tan theta plus 120 plus tan theta minus 30. Oh, sorry. Minus. Here it will be a minus. Here it will be a minus is equal to m plus n upon m minus n. Now anything which is clicking in your head? Tan A plus tan B upon tan A minus tan B is sin A plus B upon sin A minus B. So this will become sine of theta plus 120 plus theta minus 120, no, theta minus 30 divided by sine of theta plus 120 minus theta minus 30. Now you can see, right? Do I need to tell the other steps? This will become what? Sine 90 plus 2 theta. Sine 90 plus 2 theta. And this will become sine of theta minus theta 0, 180 minus 30, 90. Sine of 90, 1. Right. Sine 90 plus 2 theta will give me cos 2 theta divided by 1. Sine 90 plus 2 theta. Sine is positive in second quadrant. Yes, cos 2 theta. No problem, right? Cos 2 theta by 1 is equal to m plus n upon wait. We are doing something. Here should be a 2, right? Something wrong we are doing. Can you tell me, guys? Okay, here 120 plus 30 it will be. Yes, sorry. My bad. 120 plus 30. So it will be sine 150. Now we'll create a 2 over here. 150 means pi minus 30. Then 1 by 2 will come. And there will be a 2 over here. So finally we'll get m plus n upon 2 times of m minus n. Yes. Great to go? Okay. Triple angle. Although very rarely used, but again, remember them. Sine 3 theta is 3 sine theta minus, remember this one? Okay. Sine 3 theta is 3 sine theta minus 4 sine cube theta. Cos 3 theta is 4 cos cube theta minus 3 cos theta. Tan 3 theta is 3 tan theta minus tan square theta upon 1 minus 3 tan square theta. Now, in the remaining of the session, I'll tell you the formulas, remaining formulas which are rarely used but are used, directly used. If they are used, they are directly used in the questions. Triple angle formula. Sine 3 theta, you can remember 3 sine theta minus 4 sine cube theta. Cos 3 theta, you can remember opposite, reverse. 4 cos cube theta minus 3 cos theta. Tan 3 theta is, again you will have to remember, even if you divide these two, no, it will take a lot of time to get to this. So let's remember this as it is, 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Try to remember them as it is. Is there any +1 student? Okay, that was older comment. Okay. Okay. Remember this again as a result. Although this you can prove, right? You can prove this. Why? How? Sine 60 minus theta into sine 60 plus theta. Sine a minus b into sine a plus b. Remember? Sine a plus b into sine a minus b is sine square a minus sine square b. Remember? Sine square a, that means sine square 60 minus sine square theta. Correct? Sine square 60 will be sine theta into sine square 60. Sine 60 is root 3 by 2. So it will be 3 by 4. 3 by 4 minus sine square theta. What will this give us? This will give us 3 sine theta by 4 minus sine cube theta. So can we directly say that 3 sine theta minus 4 sine cube theta if we take the LCM, and we know what is the numerator. Numerator is sine 3 theta. So 1 by 4 into sine 3 theta. But still remember this, sine of an angle into sine 60 plus of that angle into sine 60 minus of that angle, or in some other order, is equal to sine 3 theta by 4. Remember this as it is. Get it stuck in your head. 16 into sine 10 into sine 60 minus 10 into sine 60 plus 10. That means into 16 into 1 by 4 into sine 3 times of theta, smallest angle, that means 10. So this will give us 4 4s are 16, 4 sine 30. Sine 30 is 1 by 2, 1 by 2. Directly we'll get the answer 2. You must be thinking, sir, they won't ask this type in any competition, but you have the proof. competition also can ask direct formula based question. 16 multiplied with sine 20, sine 60 minus 20, sine 60 plus 20. So 1 by 4 sine 3 times of smallest angle, that means 3 times of 20, that means 60. 4 4s are 16. 4 into sine 60 root 3 by 2. 2 root 3. Directly can also be formula based. See, they want you to actually they want your practice. Exam is seeking practice. Practice only will make you remember these type of things. When you must have solved 4 or 5 of these type of questions, no, you will easily get the answer. Again, one more example of triple angle. 36 into 4 cos square 9 minus 1. Now, looking at this, although I don't have, looking at this, I might not get any idea which option, which formula to apply, or which, how to proceed. But one thing which will catch my eye is 9 3s are 27, 27 3s are 81, 87 3s are 243. But I know that formula, I know for 4 cos square, 4 is there, 3 I want. 3 sine square theta minus 4 sine theta, 4 sine cube theta if I can apply, then I might be able to create sine 3 theta. So cos square I have. What do I do now? 36, let it remain like this. 4 cos square 9 degrees. So can I write it in somehow? So let's write this. 1 minus sine square 9 degree. Okay, minus 1. Now see, 4 minus 1 will give me 3, and 3 and 4 will also be multiplied with this 3, this sine square 9 degree. So I must be getting, I am solving only first part, next part you will understand on your own only. So 36 into 4 minus 4 sine square 9 minus 1, right? So this is giving me 36 into 4 minus 1, 3, that means 3 minus 4 sine square 9. But the problem is, I know the formula, 3 sine theta minus 4 sine cube theta is sine 3 theta, but I need sine theta, right? So I can create it. 36 into sine theta, I'll multiply inside. 3 sine theta minus 4 sine cube theta. If I'm multiplying sine theta in the numerator, obviously I'll have to divide. So this theta is actually 9. Now see, this will become 36 into sine 3 theta divided by sine theta. Right? I'm not writing 9, I'm just writing theta right now, so that you can understand. What will this become? 36 into 4 cos square 9 minus 1 will become 3 sine 3 times 9. That means sine 27 divided by sine theta, that means sine 9. Okay. What will this become? This will become sine 3 times 27. Right, so sine 3 times 27 means 81 divided by sine theta, that means sine 27. You must have got the idea what I'm trying to do. 4 cos square 81 will become 3 times of 81, that means sine of 243 divided by sine of 81. Okay, this will become sine 3 times of 243. These are 9, 729. 729 divided by sine 243. This cancels this cancels this, and this cancels this. What are we remained with? 36 into sine 729 divided by sine 9. And now what do we know? 729. That means sine 720 means 360 into 2. Okay, so 720 means 2 pi plus 9. 2 pi plus 9. First quadrant. Sine 9 only, and sine 9 and sine 2 pi plus 9 will be same. First quadrant, same sign, no problem. Answer will be 36 directly. Okay, 36 can be answered directly. Very good, Sachin. Yeah, Saurav. Epic. Good. Epic has given an epic answer. Sine 18 again. Told you that derivations will take time. Better that you remember. Root 5 minus 1 by 2. right? Root 5 minus 1 by 4, sorry. Root 5 minus 1 by 4. Directly remember. I'll show you the derivation if you want. So what you have to take as 5a, you have to take an angle. 5a you have to split as 2a plus 3a, because 18 is not favorable. 18 multiplied with 5 is favorable. 90 degrees favorable. So we multiply a with 5. 5 into 18 is 19. 5a is equal to 90 degree. We know the value for 90 degree and we know a few formulas. So what do? We take 2a is equal to 90 minus 3a. Then we take cos both the sides. Cos 2a into sin 3a. Here we'll have to use, now we can see that there will be an equation created. How will we create the equation? By creating either everything into cos or everything into sin. We have sin 3a formula. That means 3 sin a minus 4 sin cube a. We can create this side also in sin. 1 minus sin square a. 1 minus cos 2a is equal to 2 sin square a. Right? So 1 minus sin square a is equal to, we can write like this. Okay, 1 minus sin square, we are writing 3 sin. Now an equation will be created in sin. Take sin a as k. There will be a cubic equation created. Again, cubic equation, one factor you'll have to find by hit and trial. One factor, luckily you'll get 1 only. When you'll put 1 as k as 1, you'll get 0. So that means k minus 1 is a factor. You'll divide k minus 1 by this entire equation. Too much pain. Too much pain. Too much pain. So okay, Rishi, all right, too much pain. Here again, then factorize this. Either k will be equal to 1, but k cannot be equal to 1 because sin 18 we have taken as k. Sin 18 cannot be equal to 1. So what we'll do, we'll factorize this one. When we'll factorize, we'll see that middle term splitting is not is a bit difficult. So what we'll do, we'll use the quadratic formula. Quadratic formula when we'll get minus 1 plus root 5 by 4. Right? And sin 18 is in first quadrant, 18 degrees in first quadrant. We'll get two results, plus and minus. Definitely minus 1 plus minus root 5 by 4. But minus 1 minus root 5 will become negative. Root 5 is 2 point something. So it will become negative. Sin 18 in first quadrant, sin 18 cannot be negative. So we'll reject negative value, we'll only accept positive value, which is root 5 minus 1 by 4. But the summary of this entire thing is, remember sin 18, root 5 minus 1 by 4. There are many times sin 18 is directly used, directly. Okay. One more important result. Cos theta into cos twice of theta into cos twice of 2 theta into cos twice of 4 theta. How many terms? 1, 2, 3, 4. 4 terms is equal to sine, remember it like this only, is equal to sine 2 to the power number of terms. N is number of terms. Just remember n as number of terms. Okay, easier to apply the formula that way. 4 terms, 1, 2, 3, 4. So 2 to the power 4 theta divided by 2 to the power 4 into sine theta. What are we having? GP is being created in the angle, right? GP, geometric progression. Theta, 2 theta, 4 theta, 8 theta. Theta, 2 to the power 0 theta, 2 to the power 1 theta, 2 to the power 2 theta, 2 to the power 3 theta. Oh my god, it will all be equal to sine 2 to the power n. N means how many terms we are multiplying, which are where angles are in GP. Okay, so sine 2 to the power 4 theta divided by 2 to the power 4 into sine theta. Remember it as the result only. Very important result, very important result. Okay ji, right? How we may get to apply it? Can we apply it? Yeah, look. 12 into 2, 24. 24 into 2, 48. And 36 into 2. 36 into 2 also we can see 72. This is how we are going to apply this result. 84 we'll think about later. But let's do cos 12. That means cos theta into cos 2 times 12. That means 24 into cos 2 times 24. That means 48. Let's keep them together. Then 36, cos 36 into cos 72. Keep them together. Cos 84. Don't worry, bro. We'll take care of you. We'll see you in the end. Okay. 12, 24, 48. Theta, 2 theta, 2 to the power 2 theta. 3 terms. Okay, so what we'll have, sine 2 to the power n. 2 to the power n means 2 to the power 3, 8 theta, 8 into 12. Okay, divided by 2 to the power 3, that means 8 sine 12. 12 8s are 96. Okay. So let me write directly, and this will become cos theta into cos 2 theta. Cos theta into cos 2 theta, 2 terms. So sine 2 to the power 2 theta, that means 4 into 36. Theta is again smallest angle, divided by 2 to the power 2. 2 terms only, so 4 sine 36. 36 into 4, 144. And here we have cos 84. Now see, this will become 12 into 8, 96. So sine 96 divided by 8 sine 12. Okay. Multiplied with, this will become 144. So sine 144 and sine 36 can I directly cancel? Sine 36 is pi minus 144. Oh, sorry, sine 144 is pi minus 36. Pi minus 36 will be sine 36 only. Can I directly cancel? Do you mind? Can I directly cancel? Do you mind? Because see, 36 into 4, 144. 144 means sine of pi minus 36. Sine of pi minus theta, second quadrant, sine will be positive. So sine 36 only will have. Sine 36 by sine 36 we can cancel. 1 by 4 we can keep. 1 by 4 we can keep. Into cos 84. Now any other relation? Any other relation? 84. No. 90 minus 6. 90 plus 6. Sine 90 minus 6. Sine 90 plus 6. Okay. Sine of 90 plus 6 cos 6 by 8 sine 12. 8 into sine 12. I have cos 6. Sine 12, can I break it as? Acha, 1 by 4 is also there, wait. So let's keep these ones aside, otherwise we'll forget. 1 by 4 into 1 by 8 we are keeping aside. Okay. And sine 96 is sine 90 plus 6. That means cos 6. Cos 6. Sine 12, I want cos 6. Now I want to cancel this, right? Sine 12 I can write as 2 into sine 6 cos 6 multiplied with cos 84. Cos 84 means cos 90 minus 6. So sine 6, can I write it as sine 6? Sine 6, sine 6 cancelled, cos 6 cancelled. 8 2s are 16, 16 4s are 64. 1 by 64 we are getting directly as the answer. Anybody has written? No. 36. No answers. Come on guys, keep answering. 1 by 64. Great. This question we solved, right? We solved this question. Sorry for repeating it. Again, this one again same thing. Sine theta, sine 2 theta. Either that one you can use or break them like this. 11 minus 1. So I'll give you a hint. 2 sine. It's better that we speed up a little bit. See, sine pi by 2 they written as 11 pi minus 10 pi. Why? I'll tell you. 11 pi by 2. See, we are creating pi by 2 here. 11 pi by 22 will become pi by 2. Pi by 2 minus 10 pi by 22 will become cos. We'll get cos. We know a product formula in cos. That's why we have to do this. We don't know the product formula in sine. We know in cos. So we'll create all the cos. How will we create cos? By creating pi by 2 minus theta. So pi by 2, how will we create? 11 pi we can write as 11 pi minus 8 minus 10 pi. 3 pi we can write as 11 pi minus 8 pi. Okay. 7 pi we can write as 11 pi minus 6 pi by 22. Similarly, this one we can write as 7 pi, 11 pi minus 4 pi by 22, and 9 pi we can write as 11 pi minus 2 pi by 22. Now 11 pi by 22 minus 10 pi by 22, right? So 11 pi by 22 to sine of 11 pi by 22 minus 10 pi by 22. I'm just writing one more steps. This will become sine of pi by 2. 11 pi by 22 will become pi by 2 minus 10 pi by 22 will become 5 pi by 11. This will become 5 pi by 11. So what we'll get? We'll get cos 5 pi by 11, right? Similarly, by converting everything, we'll get cos pi by 11, cos 5 pi by 11, cos 4 pi by 11, cos 3 pi by 11, cos 2 pi by 11. When these all are pi by 2 minus 8 by 22, 8 by 22, 4 by 11, right? 6 by 22, 3 by 11, 4 by 22, 2 by 11, and this one also, right? Now, see, cos pi by 11 into cos 2 pi by 11 into cos 4 pi by 11. 3 pi by 11 can be written as 8 pi by 11 also, right? 3 pi, this can be converted as 8 pi by 11, yes or no? Nahin. Cos of pi minus 3 pi by 11, won't it be same? Cos of pi minus 3 pi by 11 will be minus of, so if I put a minus over here, this and this will become same, right? Over here, cos of, what do I want? 16 I want, right? I want 16. I want 16. So this will also become, this will become 16, cos of 16 pi by 11, and this will become cos of 8 pi by 11, right? Pi minus 8 pi, no, pi by 11, cos of pi minus 8 pi by 11, I have to write. Pi minus 8 pi by 11 is also 3 pi by 11. I put a minus here also, I'll have to put a minus. Okay, pi minus 16 pi by 11. If I do pi minus 16 pi by 11, I'll get the same thing. Minus minus will become plus. Or sorry, 16 pi by 11 minus pi also you can write. Minus will have to write definitely again. And finally, I'll get the same thing. Cos theta, cos 2 theta, cos 4 theta, cos 8 theta, cos 16 theta, and there I'll be able to apply this formula. This formula of cos product series is very, very important. Remember this. One important expression, A sin theta plus B cos theta. Okay, A sin theta plus B cos theta. Very important result. Remember this. Just a minute, I'll have some water. Give me a minute, please. Stay intact. You can take a break or water or something. Now see, if I have such an expression, what am I supposed to do is, this is a very important expression, although the use of it we'll do while finding the range of trigonometric functions, which we'll understand in functions chapter. For now, just a small idea about it. See, A sin theta plus B cos theta. If A sin theta plus B cos theta I have to write, can I write it like this? Root of A square plus B square, A by root A square plus B square plus B by root A square plus B square. Multiply and divide with, whenever you have to write this expression, multiply and divide with root A square plus B square. Multiply with root A square plus B square and divide with root A square plus B square. Both of them, right? Why are we doing this? Because see, square of this plus square of this will give us 1. Square of this plus square of this will give us 1. And that means that we can take this one as sin theta and this one as cos theta. Sin square theta plus cos square theta will give us 1, right? So that is why. whenever you see this, just write it like this. Whenever you have this expression, write it like this. A sin theta plus b cos theta if you have. First write it like this, root of a square plus b square multiplied with a by root a square plus b square sin theta plus b by root a square plus b square cos theta. Why are we doing this? Because it is the same. We didn't make any change. It is still same thing only. But now this square plus this square is equal to 1. So we can say that root of a square plus b square sin theta plus alpha, where tan alpha will be equal to b by a. This thing will become b by a, right? Because sin theta we are taking as a by root of a square plus b square, and cos theta we are taking as b by root of a square plus b square. So tan theta here, tan theta or tan alpha will become b by a. Sin a cos b, cos a sin b. Let's say this is sin theta for, if this is, let's say we are taking cos alpha, this is some angle alpha. Okay, this is the value for angle alpha. Square of this plus square of this is equal to 1, right? Why am I saying this? That we know that sin square theta plus cos square theta for same angle, it will be equal to 1. So if this I am taking, and the square of this term and this term is also 1. If I am taking this as cos, this will automatically become sin. And cos alpha sin theta plus sin alpha cos theta will give me sin theta plus alpha. So this into sin theta plus alpha, where tan alpha will be b by a. Tan alpha will be sin alpha by cos alpha, which will be b by a. It is just a measure of expressing like this while finding the range of the functions, which we are not looking at right now. But remember this expression. Right. Okay. Let's go ahead. Transformation. Some more transformation formulas are there. Sum to product and product to sum. Two types of transformation formulas we are looking at. Sum, from sum will move to product, or will move from product to sum. Both can be needed in any of the questions. So again, memorize. No problem. Memorize. Few only. Right? By practice, but eventually you will actually memorize all of these. If you just solve one exercise from any book or module which you have for trigonometry, from there itself you will be able to memorize all of these. Sin c plus sin d is equal to 2 sin c plus d by 2 cos c minus d by 2 plus, so sin cos, sin c minus d minus, so cos sin, 2 cos c plus d by 2 sin c minus d by 2. Try to mug them up. Okay, cos c plus cos d, cos only, but cos c plus cos d, that means 2 cos c plus d by 2 cos c minus d by 2. If it is cos c minus cos d, then it's better to remember this one directly. This formula directly you should remember. Cos c minus cos d will be 2 cos c plus d by 2 cos d minus c by 2. I'm sorry, 2 sin c plus d by 2 sin d minus c by 2. Okay, when there is a plus between cos c and cos d, you have to take cos only, 2 cos c plus d by 2 cos c minus d by 2. When there is a minus in cos c and cos d, you have to take 2 sin c plus d by 2 and d minus d by 2. Sengate or RD, yeah, RD, Sengate, there are many other books also, right? Modules, or if you are going to any coaching, solving will make you memorize. Which book is best for JEE? Many books. Sengate, RD I would not recommend, because RD, you know, you'll make a habit of reading the solved examples. Too many solved examples are there generally in RD. Objective one, yes, you can buy. Every book is fine. You know, it's on solving. If you're solving, no, you complete that, you'll automatically realize that I'll need some higher level of questions. I need more practice. Solve one first, whatever you have. You must be having too many books. Don't worry. Start with NCERT. Formula, if you want to remember, start with NCERT. Formula, same type of formula will be applied so many times, you'll remember that. You'll start mugging that up. Okay, for example, over here, we can directly use cos 4x plus cos 2x will give me cos 6x. I mean, not cos 4x plus cos 2x directly won't give me 6x, but 4x plus 2x is equal to 6x, and half of 6x is equal to 3x. That I know. Cos a plus cos d I have to apply. That means 2 cos 4x plus 2x divide by 2 cos 4x minus 2x divide by 2 plus cos 3x. Just writing for the numerator right now. This will become again sin 4x plus sin 2x will give me sin 2x plus sin 4x. Look, oh my god, something is messed up. Sin c plus sin b, sin cos, right? Sin cos. That means 4x plus 2x will give me 2 sin 4x plus 2x by 2 cos 4x minus 2x by 2, and remaining sin 3x I can keep as it is. Getting the idea? 2 won't get cancelled easily. Now 2 cos 6x by 2, that means cos 3x I'll get, and cos 2x I'll get, plus cos 3x divided by, what will I get from here? 2 sin 4x plus 2x, 6x by 2, 3x cos 2x plus sin 3x. Now you know what to do. Cos 3x you'll take common from here, sin 3x you'll take common from here, right? So cos 2x plus 1, cos 2x plus 1 will get cancelled, correct? Will get cancelled. What will you remain with? You'll remain with 2 cos 3x divided by 2 sin 3x. Again 2 and 2 will get cancelled, and it will give you cot 3x directly. So many a times you'll get to use formula directly. Cos x, not cos 2x. Where? Cos 3x, cos x. This is cos x. Very good. Thank you. It has been a long time, right? While I'm teaching. So now things will start getting mess up, right? When you continuously start speaking for a long time, no, this will happen. Don't mind. Okay. So direct application. Okay, what is this? I don't know. Leave it. Direct application you might get to use. Sin alpha plus sin beta is 1 by 3. Cos alpha plus cos beta is 1 by 4. Then find sin alpha plus beta. Let's look. Direct, either use the formula, that is definitely very beneficial. If we can use the formula sin alpha plus sin beta. Sin alpha plus beta by 2. 2 sin alpha plus beta by 2 cos alpha minus beta by 2, right? This thing is equal to 1 by 3 divided by this thing cos alpha plus cos beta. Cos alpha plus beta by 2 into cos alpha minus beta by 2, right? 2 cos alpha plus beta by 2. Now how am I getting the idea that I have to use this formula? That should also be a question. Sir, you could have done something else. You could have used sin alpha plus beta, sin alpha plus beta formula also, right? To sin a cos b plus cos a sin b. No, I don't have sin alpha directly, right? First hint is that. Then second hint is that I have given with values, and here I have a single ratio, single fraction. So there must be division, and in division most beautiful thing is that I'll get to cancel. That's what a math person would love. That's what a math person would love. So this is cos alpha plus beta by 2, cos of alpha minus beta by 2. Done. Correct? So what do we have? This also got cancelled. What do we have? We have tan of alpha plus beta by 2, right, is equal to 1 by 3 upon 1 by 4. That means 4 by 3. Now tan theta is given to you. You have to go in sin 2 theta. Now you remember the formulas. Remaining you can do, right? Just look at the formula of going from sin 2 theta to the double angle. Okay, this will be the correct answer. Here, this was simple only. See, this question came, so what you can write over here, sine 12 degree plus sine 12 degree if you split it, minus sine 72 degree. 12 plus 72 is 90, which is favorable to me. Right? 12 minus 72 is 60, again favorable to me. I'll apply sine C minus sine D over here and we'll be able to solve it. Do we have the solution? Yeah, good. So here we can apply sine C. So this will become sine 12 minus sine 72, right? So sine alpha plus beta, cos alpha plus beta by 2, sine alpha minus beta by 2, cos alpha plus beta by 2, sine alpha minus beta by 2, and cos alpha plus beta by 2. 60 by 2, 30, and 72 plus 12, 84 by 2, 42. Directly I'll get. Finally, I'm getting sine 12 degree minus sine 42 degree, sine 12 degree minus cos 42 degree I'm getting. This will become negative, right? Minus 60, minus 30 it will come. Right? Sine of minus theta is minus. So, minus we are getting over here. Sine 12 minus cos 42, again we'll apply sine C minus sine D, and finally we'll get the answer. So, formulas, again I'll tell you, play a major role here. We can reduce it in tan. Yeah, epic. That one again, we can reduce it in tan. That's what I was saying. Here, directly we can see that something like componendo dividendo only is being applied. Cos of theta upon cos of theta plus 2 alpha is equal to n is given. And look at the answers. N minus 1 upon n plus 2, n plus 1 upon n minus 1, something like that is given to us. So, how will we proceed? Yeah, it has been long, that's what. But now these things, direct formula based questions will come if anything comes from this part. Transformation formulas, direct formula based questions will come if anything comes from this part of the chapter. Or n plus 1, n by 1, right? So here let's reciprocal it, cos of theta plus 2 alpha upon cos of theta is equal to 1 by n. Do like this or do like that, anyhow you want. So cos, now again what you'll have to apply, componendo dividendo, because your options are giving you that hint. Simple thing, nothing to discuss in this. Cos of theta plus 2 alpha plus cos of theta divided by cos of theta plus 2 alpha minus cos of theta. Then cos C minus cos D will have to be applied. Try applying. And this side what we'll have, 1 plus n upon 1 minus n. Getting? Which option? Good. Good, epic. Here cos C minus cos D, if you will apply, no, you'll get a decent answer. You'll get theta plus 2 alpha plus theta by 2, right? This will become cos theta plus 2 alpha plus theta by 2, 2 cos theta plus 2 alpha plus theta by 2, and cos theta plus 2 alpha minus theta by 2. So, we'll get cos alpha directly, and another part will be cos of alpha plus theta. I'm directly writing, this will become cos of alpha plus theta upon cos of alpha plus sine of alpha plus theta, sorry. This will become cos C minus cos D, right? So, we'll have sine of alpha plus theta over here, and this cos of theta will get cancelled, cos of alpha, sine of alpha. Correct? Getting the answer directly? Cos by sine is becoming cot of theta plus alpha, and this is becoming cot of alpha, right? Cot of theta plus alpha, and this is becoming cot of alpha. 1 plus n upon 1 minus n. Which option can you tell me? Come on. Cot we wanted, we got cot, right? Cot of theta plus alpha we wanted. So this will go below this division, and I think this would be our answer, right? 1 by tan it will become, no, tan will be multiplied, 1 minus 1 plus n upon 1 minus n. Okay. Product to sum if you want to come. Just a minute. Product to sum. 2 sin A cos B. When we have product and we want to come into sum, right, we'll come like this. 2 sin A cos B will be equal to sine of A plus B into sine of A plus sine of A minus B, right? When we have a product of sine cos and we want to shift it into sum, there might be a need. It can be the requirement of the question. We'll see same questions which we solved previously. Same type of questions can be solved like this also. That is why transformation formulas are rarely used. That's what I said, because you will be able to solve the similar questions with other options or other formulas also, right? So no need to worry. We have already covered up so many formulas. Have a look at them, paste them also, remember them. You don't know where you can apply the shortcut and get answer easily. 2 sin A cos B will be equal to sine of A plus B plus sine of A minus B. 2 cos A sin B will be sine of A plus B minus sine A minus B. 2 cos A cos B will be equal to cos of A plus B plus cos of A minus B. 2 sin A sin B will be equal to cos of A minus B will come first. This one is tricky. Cos of A minus B minus cos of A plus B. Okay. Here, can we directly use the formula? Check it out. This part, we'll just get to use at this part, right? So, see, we remember, we can see this. There is sine square A minus B, B minus A, this is there. We know this formula is going to be used, but for using this also, we have to split this into sum. 2 sin A cos B, we have to split it into sum. So it will be something like this: sine square A plus sine square of A minus B plus this part we are writing as sine of A plus B plus sine of A minus B into sine of B minus A. This is why. Now when you will multiply, no, you will get your answer very easily. Very easily you will get your answer. Sine square of A minus B is being created also over here also. This will become minus of, this part will become minus of sine square A minus B. Why have I written minus? Because sine of B minus A will be equal to minus of sine A minus B. Sine of minus theta is minus theta, right? So this will become this, this will cancel this one, right? Then again here you'll apply the formula sine A cos B plus cos A sin B. This part you know, this one you can also solve with using the transformation formula. You know this, sin theta into sin 60 minus theta into sin 60 plus theta. You know answer will be 1 by 8. But you can solve this using the product also. You can solve this using the product also. You will say, sir, why then? Why should we do that? That is even more that is even sine square B. Yes, Epic, correct. No, not I forgot your name, man. Sorry, I should remember that. What did you tell your name was? Rishi. Yes, good, good. Okay, so you can use the product formula, but again it will get lengthier only. Better remember the other trick. Product formula: 2 sin A sin B cos A plus B cos A minus B by 2. By 2 also you have to do, because that is 2 sin A sin B. Again same answer you will get, but in a lengthier way. So it's your choice. Many questions. Now trigonometric series. Sometimes, one very rarely, but yeah, a question has been asked from this part also. Very not here, nothing difficult to remember. It is like an AP only. Okay, sine, angle, AP inside angles. AP inside angles. If you find an AP inside the angles of sine, you should use this. Sine alpha plus sine alpha plus d, sine A plus sine A plus d plus sine A plus 2d. Then the sum of this trigonometric series will be equal to sine nd by 2 divided by sine d by 2 multiplied with sine A plus n minus 1 d by 2. Remember it. This, I'm sure, once more or once again a question can come. So remember this as it is. Yeah, Rishi, just a little more, just a few more. Now I'm just telling you not so important formulas, but yeah, it's JEE. You'd never know about JEE. General pattern, whatever we see type of questions, we have solved that part, we have understood that part, but this part also keep a note of it at least, or take the screenshots, although I'll be uploading the PDF, but still have a look. Sine A, if you have a arithmetic progression in sine, then it will be sine nd by 2 upon sine d by 2 multiplied with sine A plus n minus 1 d by 2. Arithmetic progression in cos, it will be sine nd by 2 upon sine d by 2 multiplied with same formula, same series. So it's not difficult also to remember. Here there is sine, here there will be cos, that's it. This part will be same, sine nd by 2. If we get time in some other class or someday, maybe if we keep interacting like this, we'll derive this also. For now, sine nd by 2 upon sine d by 2 multiplied with sine A plus n minus 1 d by 2 if arithmetic progression in angles of sine is there. If arithmetic progression in angles of cos is there, then sine nd by 2 upon sine d by 2 multiplied with cos A plus n minus 1 d by 2. Remember this. Okay, like this. AP only. How many terms? A is 4, D is 2. Where are we going till? 180. So 180 is equal to A plus n minus 1 into 2. That means 180 minus 4 minus 2, 2, 180 minus 2, 178, 179 terms. We'll have 179 terms. Formula directly. Hey, no, 179, sorry. Did we... 170, oh, sorry, my bad. Right. 90 terms are there. Okay, 90 terms are there. Sine nd by 2. 246, difference is 2, first term is 2. Right, total 180, so 90 terms are there. By logic also, we are getting the same answer. 90 terms will be there. Right, direct formula application, sine nd by 2 upon sine d by 2 multiplied with sine A plus n minus 1 d by 2. We are getting sine 90 by sine 1 into sine 91. Sine 1 and sine 91. Sine 90 is 1 only. Here we will get cos 1. Cos 1 by sine 1, cot 1, directly answer we are getting. Right, same arithmetic progression, pi by 7 plus the difference will be 2 pi by 7. Difference will become 2 pi by 7. Same formula you have to apply. The total number of terms are, how many terms are there? 3 terms only are there, right? So directly 3 by 2. Sine 3, 2 pi by 7, n into d by 2. Divided by sine d by 2 and sine into n A plus n minus 1 d by 2. Remember the formulas, direct apply. Solve them once on your own. Solve them once on your own at least. Okay, here you will also get to use 2 sin A sin B. You will also get to use 2 sin A sin B over here. 2 sin A cos B or 2 sin A sin B, I think. Yeah, 2 sin A cos B you are getting to use. Right, so solve these questions once on your own, easy direct formula based questions, but you will be able to solve. Conditional identities also again rare. This you know already, right? This you know. All of these are applied when A plus B plus C is equal to pi. Make a note of them. If A plus B plus C is equal to pi, then only these identities are valid. Again, something to memorize. This much part is there in trigonometry, 11th class at least, and these things will be used in further chapters, other subjects, everywhere. Major part we have solved. Remaining mugging up part, you can still I'm not saying that this never comes or this is not so important. This is also important, but rarely, much rarer than the other part. And directly, these are, if it will come also, no, it will be directly formula based. So you will be able to apply formula. Sin 2a plus sin 2b plus sin 2c will be 4 sin a sin b sin c. Cos 2a plus cos 2b plus cos 2 will be minus, cos 2c will be minus 1 minus 4 cos a cos b cos c. See, how to remember or how to mug up, I've told you, simple thing. Walk, once mug up, write down, it will get inside your head. After that, whatever you have written down, paste it somewhere in the room's wall and keep reading it whenever going or coming into your room. So it will stay intact in your heads for at least the time till you give the examination. So nothing to worry about. Integration, next chapter, yeah, quadratic will start. I'll try, Saurav. Quadratic, binomial, PNC, we have limits and all. Before limits and all, we'll try to cover up functions. Okay, so that functions, if we can get a good grip on, limits will also become easy. All right, sin A plus sin B plus sin C can also be written as 4 cos A by 2 cos B by 2 cos C by 2. Tan A plus tan B plus tan C, you know, it is tan A tan B tan C. Tan A by 2 tan B by 2 plus tan B by 2 tan C by 2 plus tan C by 2 tan A by 2 is equal to 1. Direct result. Direct result. Again, there are some questions which you can refer to, but direct formula based. Everything is going to be direct formula based. Nothing to worry about. Okay. This proof you know already. This one proof you already know. So you can prove them also. All of them can be proven very easily. Not a problem. Proofs are there attached in the PDF. You can go through them. Triangle based questions. Mostly triangle based question. They'll say that these are the angles of a triangle. So A plus B plus C is going to be equal to pi. Remember that. Okay, that means you have to use conditional identities. In that case, you have to use conditional identities. Nothing much. Nothing manipulation or nothing else you'll have to do. This one question here, you'll have to choose. Here what is given? X plus y plus z is equal to xyz is given to you. So x plus y plus z is equal to xyz directly is giving you a hint that tan A plus tan B plus tan C is equal to tan A tan B tan C. Simple. Direct application. So you can take x as tan A, y as tan B and z as tan C. Remaining question you will be able to solve very easily. Tan 2a identity, remember. Tan 2a, 2 tan A upon 1 minus tan square A. Tan 2a you can remember by tan A plus A also, but remembering these identities will always get to your solution faster than any other method. Trust me, memorizing is the only fastest way here. Generally, I don't say that. In maths, definitely I don't say that generally. But this chapter is going to eat up your heads if you cannot remember the formulas. It will start making you hate math. Trust me. All the formulas are there. Same thing you can write neatly or take a printout, or better write neatly and then stick it on the walls of your rooms so that you can remember them for a long time and they'll keep helping you. All right then, I think last but not the least, this thing. Don't forget to revise the entire chapter and write all the formulas and identities on your own. Thank you so much. I am also tired. All right, so subscribe the channel. Okay, we'll have more. If you have not, then please do that. We'll have more of such chapters. We'll learn more of concepts. More of videos will keep coming up. Guidance towards IIT JEE exam and much of stuff we have planned. Akash sir also is going to some questions. Some students were asking about Akash sir. He's also going to take some lectures, but maybe he might be busy in something else, or So for now, you'll get a complete combo. Don't worry about it. The channel you can subscribe. You should subscribe. There is no language barrier. You can easily understand things in English. Everybody can understand things in English. In fact, whoever knows other languages also, English is fine. We don't speak that fluent of or that difficult of English, which you will be unable to understand. So don't worry about it. Don't bother about it. Thank you so much. Thanks a lot. Have a good night. Tada. Thank you. Thanks a lot.